when there is a cold war between Russia and USA, so Russia launched a satellite, their first satellite in the space, that is, I think, Sputnik something, and they are getting signals. Somebody is jealous, made two organizations, that is DARPA and NASA, at the same time. They actually started two organizations. You already know this. So DARPA is Defense Advanced Research Project Agency. So actually what they have done, so they have, like in USA, they have underlaid the cables to connect multiple defense sites. Okay, maybe New York, maybe somewhere like another areas of US. These cities are connectivity between army projects, right? So basically this group is made to create a network so that all the cities or all their armies can communicate with each other. So when this project got famous, they actually released a public version of it that is known as Advanced Research Project Agency, that is ARPA. Okay, so ARPA means when they launch this, like suppose I'm a builder, okay, I'm making a very big 1000 flats or maybe big project. So I'm going to ask investors to put down their money in my project, right? So when Advanced Research Project Agency came, like some investors, like those are known as now ISPs, like they came into picture and they invested to put down the cables to connect the cities. Like when people are actually investing to create a big network, now they are known as tier 1 ISP. So what is tier 1 ISP? Actually invested in the cables, so that is known as tier 1 ISP. So like to become a tier 1 ISP, tier 1 ISP is like the king of ISPs. So tier 1 ISP is actually giving connections to tier 2 ISPs. There are a lot of tier 2 ISPs in the world also. All they are taking connections from tier 2. For the backup, they are taking from multiple tier 1s. And these tier 2 ISPs are giving connections to the local ones, which are known as tier 3 or local ISPs. So these are very small ISPs, like maybe you have in your hometown, but it's not in another cities, tier 3. And users can connect to these ones also, and these ones. So who are tier 1? Like I remember few names like AT&T, level 3, Sprint, Comcast cables. So these are from all US. Australia it's Telstra. In India only one name, Tata Communications. Japan and all, they have Singtel, Entity Communications. So you can just Google it, tier 1 ISP, you will have around 15 to 20 names. Means only 15 to 20 ISPs in the world are actually investing in big projects. And that big projects actually, they are investing in most of submarine cables.
Before moving further, we have something special for you. If you want to learn hacking and other major tactics related to cybersecurity, you should definitely enroll in our Cybersecurity Masters program, where you will get more than 150 hours of live training directly from industry experts, with 24/7 access to world's biggest virtual labs. Apart from this, even if you want to make career in in-demand IT field and want to land a good package, we have master's programs for them too. Enroll now, link is in the description. Now let's continue.
So I'll start with what is network. So like if two computers are connected, they are all, this is also a network, right? So computer A is connected to computer B, so they can share the things with each other, they can send files to each other. So this is a network also, right? And if multiple computers are connected, 4 computers or 4 devices are connected with a device which is known as switch. Okay, so this is also a network. When 4 computers or 4 devices are connected together, that is also a network, right? And when we talk about, like suppose I'm sitting in India right now and you will be taking this session from US. Okay, so we are also connected, right? But how we are connected? We are connected with service provider network. Okay, so you have your own ISP. Suppose you have AT&T and in India I'm using maybe Geo or whatever, right? So all these ISPs are connected together. with a cable that is submarine cable. Okay, so this is also a network. So means network can be like 2 computers are connected together, and network can be like a 4 or 5 computers are connected. So computers, PCs, laptops, mobiles, you can say anything, any host. So we can say that host. So what is host? So host, basically any device which gets the IP address is known as host. So PC is host, laptop is host, server is host. So when we say host in networking, so host means the any device which gets the IP address, that is host. Okay, so PC, laptop, servers, all these machines are your host. Okay, so got my point, right? So this is network. And what is networking then? So networking means when they are going to share the data. So suppose you are watching my screen right now. So we are sharing resources with each other. So sharing of data and resources is known as networking. Okay, so what is NIC? What I told you. So NIC is this chip called network interface cards. And long time back, 10 years, 15 years back, so every computer, like in every computer, we have to buy separately this NIC card, which we add in the PCI slots. Okay, it's a chip basically. You can see that, and we have to place this in the PCI slot. This is what we call PCI slot. This is motherboard. तो हमें ऐसे लगाना पड़ता है basically. Okay, we have to add like this. This is very, very old, like 10 years, 15 years back. Okay, but nowadays all the motherboards and computer don't have MAC address. Okay, but where we have MAC address? We have MAC address on this chip. Okay, we have MAC address on this chip. And nowadays, all the motherboards already have this chip inside. You can see some slots. So these NIC cards are already inbuilt on motherboard. So you do not have to buy separately now. So this is what we call Ethernet port also. LAN port, Ethernet port. Okay, Ethernet port would be more good term. Okay, so nowadays we have 2 cards, 3 cards, depends on your motherboard. You have multiple ports also. So these are called NIC cards. Okay, so these are called NIC chips. So after that, if we want to connect the 4 computers together, okay, so then we buy a device which is called switch, okay, or hub. Earlier it was hub, but hub has a problem. If you send data to one computer, data will go to all computers. So hub we do not use nowadays. So in hub, we connect all computers. You can see the cables are connected with computers like this. Okay, so this is how we connect computers, like 8 computers together. Okay, so it is not used anymore because if you send data, you can see send data, it will go to all computers together. So this is what we call broadcast. If you send data to everyone, this is called broadcast. क्या बोलते हैं इसको? जब एक जगह भेजना डेटा और सब जगह चला जाए. If you send to one machine but go to everywhere, that's called broadcast. Okay, it's a problem because bandwidth utilization will go high. Okay, so this is what 2 devices we covered, NIC and hub. Then we bought a switch, which is more powerful device. Okay, where we connect all computers and there is no problem of broadcast. If we replace this hub, if we replace this with the switch basically, अगर हम इसकी जगह switch लगा दें, so switch will only send to A computer to B only because switch learn MAC address. That okay, packet is coming from A, computer is going to B. So switch learn MAC address. That's why it is going to the same computer. So he is saying, I am the B computer, please only send to me, and other computers will reject the packet. Okay, so after that, we have a device which is like the father of network devices. Okay, router. So basically, if you want to connect 2 different networks, because 2 different networks by default, they cannot talk. Internet is also a different network. So why you always need a router in your home? Why everyone have Wi-Fi devices at home, router, what we call router Wi-Fi devices? Because all these devices connect with a different network. Or router क्या करता है? What is router? Connect two or more different networks together. This is how we build internet. Lot of network devices, routers are placed on internet. Every college, university, campus, companies, they all have routers. And all these routers, even big ISP also have routers. This is how your data is going to Google and Facebook. All routers are forwarding your data to Google, Facebook, anywhere, because routers are forwarding your data. They check routing table, they check and forward data. Okay, so everywhere, every company, medical, hospital, everyone is using routers, and these routers are helping us to connect with each other. So which cable we place between routers normally? WAN cable. So what are WAN cables? So some cables are undersea. Obviously we can't put so big ISP, they have lot of routers, and they have cables, okay, and they connect routers with cables, obviously, and these cables provide connections to home, offices, and all these things. So I'll explain what is a switch. Okay, so switch is a device which is used to connect two or more hosts or two or more computers. So what you will do when you have two or more computers, let's take an example. Suppose we are 4 guys and we want to play a LAN game like Counter-Strike, Call of Duty, and anything, right? We want to play together. What exactly we will do? We can buy a switch from market, which is hardly $10 to $15, right? And we will connect all our devices with this device. This is a switch. When we buy switches from Amazon or from any website, it starts from $10, and like we have a very big companies like Cisco, Juniper, HP, Aruba, and many big companies. They have $2,000 switches, they have $20,000 switches. But what is the difference between this $10 and $2,000? Basically features. So in a normal $10 switch, when this device wants to communicate with B, the information will pass on to D also, C also. So this happens with the local switches, which are known as unmanageable switches. So unmanageable switches are an extension to the devices. Like suppose you have extension board, what we call, where you get multiple ports, and you can put your charger, laptop charger, and other things, right? So the same this unmanageable switch is like, this is just an extension so that you can connect multiple devices. But when we talk about manageable switches, so they have a lot of functionalities, like VLAN is a concept. So all your industry companies or big firms actually uses manageable switches, so that we can use good features in these manageable switches. Okay. So switch is nothing. When we want to connect devices in a company, we use actually manageable switches. And when we just want to play games or just want to use at our home offices or a very small offices, we can use unmanageable switches. What is the example of unmanageable switch? I'll show you something. See, this is an unmanageable switches. So you can see it hardly costs $10, $15, $20, $17 device, which will help you to connect 4 to 5 machines. So you can see, so it's a $17.9 and $18 device, which will help you to connect at least approx 4 to 5 devices. So you can see 5 port. So it means you can plug almost 5 devices in this device, and this is unmanaged. You can see here, unmanaged. So in industry, you can have around 24 port, 8 port, or 48 port also. So you can able to connect 48 devices. So that is unmanageable device. That is very cheap. Yeah, but you can see here managed, but somehow it's a smart managed or partially managed. So it is giving you option of VLAN, But if you go and buy the Cisco switches, which are, or HP switches, so they are very costly. So these, even Cisco makes very small devices nowadays. Okay, but this is hardly $60. But when you go into the industry side, it will cost more, or maybe $1,000, or maybe you can see this. So I'll show you one device that is 3850. So that model is 3850. So Cisco has a device that is also a switch that will cost around 3000 plus, or maybe this is a new, or you can see the actual price is $14,000. Maybe this is the old one or refurbished one. Okay, so this is the difference between managed and unmanageable. Okay, so what's the difference actually? So unmanageable is like very basic functionality just to get the work done. But in manageable switch, we get VLAN features and lot other things. So this is the difference between unmanageable and manageable. It has like 250 computers. Okay. So all these PCs have one chip that is known as, all machines, all laptops have one card that is known as NIC card. So that is network interface card. So you can check your laptop right now. You may be having some port where we can put down the cable, or maybe you have wireless, right? Why maybe you should have this wireless card. So all these chips are known as NIC. So either we have wired NIC where we can put down our cable, and we have wireless NIC. So what is this NIC? NIC is a chip or any type of part which is actually helping you to connect your computers with the network. Okay, so you are adding the network cables into the computers. Like this chip is nowadays integrated in the motherboard, so we don't have to add this. But few years back we need to buy a separate card to install in the PCs, but nowadays it's pre-installed into the motherboard. NIC card is basically your Ethernet port. Yes, when we say we have Ethernet port in our laptop, that actually means it's a NIC. And do you know your computer does not have any MAC address? Your NIC chips have. It means if my laptop has wired NIC, means and wireless NIC, and a Bluetooth adapter, Bluetooth NIC. So it means if I have three things in my laptop, it means how many MAC address we will have? 3 MAC address. So this is not an address which we are giving to any computer or machine. This is a hardware address which is actually address of these chips. Either it is a Bluetooth, wireless or wired. So how many MAC address you have in your laptop, just count the NIC. Okay, so NIC you can count, you can check with the help of which command? ipconfig. Okay, so I'm using MacBook here. So if you are using Windows, you can type ipconfig right now and you can see all the details or your NIC. So I'm in Linux and in MacBook we have ifconfig. Okay, so in ifconfig, so you can see a lot many ports here because some are virtual ports. Okay, virtual means that is created just for the virtual purpose like VMware and all. Okay, so you can see here EN0. So my computer is getting this IP address right now, 192.168.1.3. So I was discussing the question. So we have around 250 computers, remember? Yeah. So when we have all these devices are connected with the device we call this switch. Suppose these type of NIC have a speed. Nowadays we got 1 Gbps, but old laptops have 100 Mbps. So suppose all the ports, so do you know what is kbps, mbps and all these things? So we have 0 and 1, these are known as bits. Okay, so when we have 8 0 ones, either it would be 0 or 1, that 8 bits are known as 1 byte. So like 0 1 0 1 1 1 0 0. So what is this? This is 1 byte. Okay, so when we have 8 0 and 1s, computer understand this 1 byte. Okay, and when we have 1024 bytes, when we have combo of, this is a group which is byte, when we have 1024 similar 0 1s, that is known as 1 kilobyte. Okay, obviously then you know KB, and when we have 1024 KB, what we call this 1 MB, megabyte, and then we have gigabyte, terabyte, petabyte, hexabyte, exabyte, zettabyte, a lot of many bytes. Now if all my devices are 100 Mbps, right, so how much throughput they will get, means how much data they can send or receive, maximum 100 Mbps. And let's take another example. All devices should have good speed, right? Suppose you have 1 Gbps and your computer has 1 Gbps, but you have a device which is only supports 300 Mbps. How much speed you will get? 300, right? Because between the transmission, if any device have low bandwidth, it means you are going to get the same bandwidth. Okay, so I'll show you one trick from ISP side. You have very good laptop and you have 1 Gbps port, you got an internet connection also 100 Mbps. Okay, so you are paying for 100 Mbps plan. Suppose you are paying $50 or approximately 2000 Indian currency. So you are paying for this internet connection, but you think that you are getting 100 Mbps connectivity. Okay, and when you are watching a video from YouTube, but you are getting a delay, means it keeps on buffering, and you always complain to this local ISP, man, you have given me 100 Mbps, but I'm not able to watch this YouTube in 720 pixels or 1080. Why? Because maybe this local ISP giving you 100 Mbps link here, but maybe they have a 100 MB or maybe low bandwidth link over the internet, because they are also taking connection from somewhere, right? So they say 1 Gbps 100 Mbps, but when you actually do the speed test, they go to their server only. Okay, I'm going with speed test. Okay, so I'm checking speed test. So by the way, I'm in North India right now in Chandigarh. Okay, so I'll check. This is a small ISP I'm using, Fastway. Okay, so let me check the speed. Go. My ISP is giving me around 90 Mbps and upload speed also 90 to 100 Mbps. Right? Are you getting now? So you always go and check, okay, and they show you the speed test, but exactly it doesn't mean you are actually getting 100 Mbps over the internet. But again, I'm going to speed test, but I'm going to choose another server. Maybe it's in Bangalore or maybe somewhere, or maybe let's check in New York. Let's test any server in New York. So let's test how much speed actually. So you can just check the speed outside India and you will be actually getting that speed only. So you can't go more than that. So let's see. It's going good. Might be my ISP is good, right? See, if New York is giving me 70, it means my ISP is good. This is how you check your ISP. So just check with another country ISP or any location and you will find this actually gives me. So mine is better because I have around 3 connections at my home and I'm using this one because this is the best one. Router. So router is also like, you can say that it's a manageable or unmanageable. When we have this device at our home, so we actually think that this is a router. But this is not a router. This is actually a device which is a combo of a router, modem, these type of technologies, and this is what we call ADSL device or DSL device. Okay, so what is ADSL? That is asymmetric digital subscriber line. So the type of device you are looking at right now, maybe that device is not a router. So that is a ADSL because it has a functionality of modem. So why we use modem, by the way? So modem is actually doing modulation and modem also does the demodulation. So when we get any type of signals, they are coming in the form of analog signals. So when the signals are coming to your device and your computer understand digital signals, right? So we can't send analog signals directly to the system, to the PC. So this is the reason we have, or ISP put down one device, that is ADSL. So this device is actually converting your analog signals into digital signals and sending those signals in the form of 0 and 1, and computer understand those signals, and the same way it is giving back digital signals, and ADSL is converting these digital signals again back to the analog signal. So this is modem, and this modem is actually integrated into this device ADSL. And now ADSL has one another functionality, router, because this device is actually created for multi-purpose. Router, modem, it has a 3-4 ports outside also, like it has a small switch inside also. And this is a very cheap device which is used by ISP to provide the internet connectivity. Yeah, it goes with the fiber also. So this is what fiber modem does. Router. So router is also, like, you can say that it's a manageable or unmanageable. When we have this device at our home, so we actually think that this is a router, but this is not a router. This is actually a device which is a combo of a router, modem, these type of technologies, and this is what we call ADSL device or DSL device. Okay, so what is ADSL? That is asymmetric digital subscriber line. So the type of device you are looking at right now, maybe that device is not a router. So that is a ADSL because it has a functionality of modem. So why we use modem, by the way? So modem is actually doing modulation, and modem also does the demodulation. So when we get any type of signals, they are coming in the form of analog signals. So when the signals are coming to your device and your computer understand digital signals, right? So we can't send analog signals directly to the system, to the PC. So this is the reason we have, or ISP put down one device, that is ADSL. So this device is actually converting your analog signals into digital signals and sending those signals in the form of 0 and 1, and computer understand those signals, and the same way it is giving back digital signals, and ADSL is converting these digital signals again back to the analog signal. So this is modem, and this modem is actually integrated into this device ADSL. And now ADSL has one another functionality, router, because this device is actually created for multi-purpose. Router, modem, it has a 3-4 ports outside also, like it has a small switch inside also. And this is a very cheap device which is used by ISP to provide the internet connectivity. Yeah, it goes with the fiber also. So this is what fiber modem does. So this is like network topologies. Okay, so what is network topologies? So there are few designs actually how we can add router network devices in our company. Okay, so the first topology is called bus topology. Okay, where this is very old design, guys, where we have one cable and you connect all computers with that cable. This is called bus topology. We have only one cable and where we add all the computers with one cable. So tell me, if one cable goes down, what will happen? Yes, network will go down. This is the problem. That's why we do not use this topology now. So we just want to know, okay, this is a topology, very old, dated, outdated. We do not use bus topology now. After, you can see we are sending data, but if cable goes down, right, what will happen? The whole devices, they will not get data, right? This is a problem. Cisco want you to understand these. So bus means they are just traveling if one link goes down. So the other topology is called star topology. This is the mostly used topology because star means you connect a network device called switch. And when you connect cables with that switch, when you actually connect computers with a network switch is called star topology, because you can place all computers anywhere. You can add multiple connections together. That's called, it is star topology. Okay, so this is called star and this is the most commonly used topology. Lot of companies are using star topology. Then we have mesh topology. Mesh means like computers connect with each other with all the cables. But this is very, very costly. But understand, because how many ports, LAN ports you have in your computer normally? One. And nowadays, all laptops, they even don't have. Like if you buy MI, Redmi, all these laptops, they don't have even single port. Even MacBook also do not have this Ethernet port. Okay, so these companies don't have the LAN ports. Okay, but now try to understand this partial mesh means you connect your computers with each other. So do you find this is relevant nowadays? Because do you buy 3 LAN ports for your laptop? So we do not use partial mesh. But if we consider, if now consider these laptops are my office routers. This is Delhi, Mumbai, Chennai, Kolkata, 4 offices. So do you think now partial mesh is okay? So then it is in the WAN connectivity, wide area network, which means if you are a big company, obviously yes, you can use that, right? You can connect Delhi to Mumbai, Mumbai to Chennai, Chennai to Kolkata, right? So ye partial mesh topologies are not used in LAN networks. Partial mesh can be used in WAN networks when you connect routers with each other, not computers. In LAN network, we do not use because it's very, very costly. What is full mesh? You connect all computers with each other. That's called full mesh, okay, which is very costly. And we have partial mesh where you connect just a few 3-4 links with each other, but not all links. Okay, so this is what we call full mesh. And partial mein kya tha? Partial has 3-4 links like this. This is partial mesh because this second computer and the fourth computer is not connected because they are connected with the first and this one, third, right? So this is called partial, means there are not all computers are not connected to each other. But when all computers are connected to each other, that's called full mesh. Okay, so there is a formula how many links are required. Like if there is an example like n-1 is equal to 2. Suppose you have 5 computers. Okay, put 5 here. Little bit math, not too much. So 5 minus 1, 4. 5 into 4, 20. 20 divided by 2 is 10. So for 5 computers, how many links are required? 10 links. Because you connect lot of links, the total links. And there is another very old topology. This is also called ring topology. Like a ring, you can see the data will come to you one by one. Okay, it is like a ring. Okay, but normally we do not use a ring also in the LAN networks. But this ring is also used in ISP networks. If you join Airtel, if you join Reliance, if you join any ISP, what is ISP? Internet Service Provider. Internet Service Provider hota hai. But ISP, big companies are using, means they are connecting their routers. This is like example of big router. So they are connecting their big routers in a ring. Like you can see all these routers are connected together and they are forming ring networks. Big companies are using ring networks where they put routers connected with each other. Okay, that's called ring network. Okay, so used by ISP nowadays. Okay, so normally what we learn from this topologies, we have bus topology, star topology, partial mesh, full mesh, and then I told you that ring topology. Mostly we use which topology? Star. Now in network, we have like in industry, we call this LAN and WAN. So what is LAN and WAN? So LAN is local area network. And what is WAN? That is wide area network. Suppose you have your own office, say this office is in Mumbai. Okay, so this device, this icon is of a circle with this like 4 lines. So this is a representation of a router. Okay, so why I'm adding a router here in Mumbai? Because maybe I have another router in Chennai. Okay, so why we have 2 routers? Because when we connect with the different networks, we need a device that is known as router. So let me take an example. Suppose you are sitting at home, you have a broadband router right now, and the router is connected with internet. Okay, so you have your own mobile phone, laptops, okay, which are connected with the router. Okay, these devices or these PCs are connected to internet. So what is internet? Because a lot many companies and users are connected, that is internet, right? So this device router is helping you out when you have your branch in Mumbai and you have another branch office in Chennai. If you want to connect both the locations, so you need a hardware device that is known as router. Okay, got it? Okay, so we have a device which is a switch. So it has a ports where we can connect our computers, servers, printers, or any type of network device, and this switch is actually connected with your router. Okay, so this area, you can say that this is a LAN network, right? And Chennai also have same type of terminology, that we have a switch, all my computer servers are connected together, and that is also a local area network. And this we can say that this is a wide area network. And now WAN, so this wide area network doesn't mean like we are connecting 2 locations only, that is WAN. So WAN can be of 2 types, that is private and one is public. Okay, so public means internet and private means your private connection. Or if you don't want to pay a lot, you can just use internet connections. So Mumbai device is connected with internet and Chennai is also connected with the internet, right? So now with the help of internet, you are actually connecting your Mumbai and Chennai, that we can say that this is a VPN. Okay, so when you want to connect Mumbai and Chennai location with internet, at that time we can say that we need to create a VPN connection between Mumbai and Chennai, that is your public WAN. So this type of network is known as public WAN, when you are actually using public resources and connecting your locations. Got it? And when we have enough money and we want secure connection, we can use a dedicated line, that is known as private WAN. But yes, we don't have enough funds to invest a cable between Mumbai and Chennai. So who is going to make or create a connection for you? ISP. In private WAN, your ISP will be same for on both the ends. Like in Mumbai, also you are using Airtel, and in Chennai also you have to use Airtel. Then only Airtel can create a virtual connection or hardware connection, lease line, many type of ISP connections available. Right, like MPLS, L2 VPN, L3 VPN, there are a lot of other connectivities that is too advanced right now for you. So just understand, like in WAN, we have 2 type of connections, private and public. So when we connect all our offices with internet, okay, so that is public WAN. And when we connect all our offices with the dedicated line with a high cost cable or leased line, you can say that. So that type of connection, you can say that private. So private is costly and secure, but so it's a secure connection because nobody is in between the connections. But in public WAN, it's internet, it's not costly, it's a cheap connection, but yet it's not secure. So this is the reason we have to use advanced technologies like VPN, IPsec or other type of thing. Okay, so that is the difference between local area network and wide area network. So ISP. What is ISP, by the way? Internet Service Provider. Okay. So ISP is giving you connection, and you have this device which we call this ADSL. Okay. It has a Wi-Fi, but it has a limited range. It only goes up to 100 square feet area, big house, and you want to send these signals to another part of the room. So what you will do, you will put a Wi-Fi router here, which we have seen right now, and we can place a Wi-Fi router here to extend the range basically. So ADSL is required when you are getting the connectivity in the form of either this type of cable. We used to use this PSTN cable, like public switch telephone network cable, either in the form of fiber. So when you are going to get the fiber connectivity, we are going to use fiber modems. So ADSL, fiber, sometimes ISP gives direct Ethernet connectivity also, or what we call this copper cable. Sometimes I have seen this, but it's not common. So this is PSTN is common and fiber nowadays is common. Fiber modems I explained, like when any device or any ISP is sending, because light has more speed, right? So when we are sending data in the form of light, right, this fiber modem is actually converting your light signals into electrical signals, because your computer still don't understand what we call this light optical signals, because your computers does not have that type of chips, those who understand light signals. But when you go into this corporate world, your router actually gets fiber cable directly into the port. Means we can place fiber cables inside our routers. So how? Why we can't put fiber cables in computers? These type of routers or any high-end devices, or nowadays servers also, so they have a small chip that is known as SFP. So this chip is known as small form pluggable adapter. So this chip is like a small modem which is helping you out to convert your light signals into electrical signals to the router, which actually converting your optical signals into electrical signal. This is the work done by SFP. But high-end devices can, like in a server, in a routers, we can place fiber cables directly because of this small chips, SFP. ADSL, you are getting a ADSL, you have 4 ports outside ADSL, and you can just connect a Ethernet cable to your Wi-Fi router and put that device into bridge mode or any type of mode. It will show you the all the functionality Wi-Fi router. Okay, so I'll show you what is SFP. So SFP, a small chip, or you can say that it's a small part. Okay, so this part is actually, we are putting this part inside the servers, routers, so that it can convert optical signals into electrical signals, because we can't put optical signals directly into the devices. So you can see here, all the Cisco devices or all other company devices are using these type of ports. We are not putting directly fiber cable into the device. We are putting this SFP first, and then we are putting or adding the cable. Clear? What is the SFP plus? SFP plus means 10 GB. SFP is 1 GB. SFP plus is 10 GB. So suppose this is your company. So now you have 2 routers. So you have core switches, then you have access switches, and then you have computers. So all these computers connect together. So all these access switches connected to the core, both switches. Okay, so these are called core switches, these are called access switches. Okay, so these are called computers, which are called end device. Okay, and these routers then connected to the routers. Between these 4 devices, we need to share information with each other. Here we run OSPF. It is a very small network. So after that, if you connect it to ISP, okay, here, so maybe this is Airtel. So here you run maybe BGP, and another side maybe you have Geo, any other company, and you are using normal default route. This is you are running BGP. This is your internet connection. Both are your internet connection. So now you have a branch maybe in Mumbai. They have the same model, 2 routers, 2 switches, and then there are some computers. It's not a very big branch. So maybe simply switches are connected with the 2 routers, and you have private connection, okay, or over the internet, because this branch also have taken the internet from Airtel, okay, or maybe from any ISP. It's not mandatory to take internet from Airtel. You can take internet from any company. Suppose we have taken that connection from Tata, okay, and over the back end, Tata and Airtel also part of what internet, yeah. So now what you want, your OSPF network will connect with this OSPF network over the internet, and this technology is called VPN, okay. So you can run OSPF here, you can put all these devices in area 0, you can add all these branch routers in area maybe 1, okay. Maybe you have another office, and that office also have some routers, switches, computers, printers. So that routers are also connected with ISPs, okay, and these ISPs somehow connected, and you can also create a VPN tunnel from this router to this router. And once you connect the VPN, which is called site to site VPN. तो जब आपने एक बार VPN में जोड़ लिया, once you create the VPN connection from your head office to branch office, then it is your choice how you will share this computer, how they will communicate with these computers. You can run OSPF in internal network only. You can run over the internet with VPN, but without VPNs you cannot run OSPF. Okay, the another thing here, you do not want on internet, you can take MPLS link, which is private connection, very costly. You can connect direct MPLS. MPLS is also a connection, but not internet. It is just a dedicated connection so that your router connect with the head office and branch office. Because internet is not secure, that's why companies use MPLS or these technology for secure transfer and better reliability. Because on internet you can't rely, but on this dedicated connection you can. This is good for applications. Just imagine if you have a head office and a very powerful server, which is like your company email server. So all employee email IDs are working because of this email server. If you lost connection with head office, you can't even send email. So that's the reason maybe companies do not depend on internet. They go for this MPLS connectivity. So when you will have a router in your office, okay, and maybe you have 4 networks. So if this router has different network, 192.168, 1.0, 192.168, 2.0. So it may be 192.168, 3.0, 192.168, 99.0, something like that. So why it's better to always do subnetting? Because when this router is going to share that information to this router, so router will have all 4 networks. So instead of sending 4 networks information, it's better to have one network only, because it is going to take less amount of space in the routing table. This router will get only 1 or 2 routes and can access anyone. So one another example, if you have very big site, maybe hundreds of routers, all your company routers are connected with maybe big routers. So all branch offices are going to send the information to you. Okay, this router is going to have a lot of routes. So if you are sending 4 network, it will have a very big routing table, a lot of entries. So if your routing table is very big, so it means there is a load on our router RAM. Like when we install a lot of softwares, they get slowed down, or maybe they keep on restarting, or blue screen comes, right? If you have a lot of many routes, what will happen? So your main routers can have a lot many routes, and can lead to either you need to buy a very premium hardware or very big router to manage these routes. You need to short these ones. Instead of sending four routes, I'm going to send only one route. So means if router is sending 192.168 1.0 from here to another router, so router will have only one route, 192.168 1.0 in the table. But here I'm going to divide this network into 4 parts, and I'm going to create 4 computer labs. We have 100 plus routers or maybe 1000 routers in our company. Whole, suppose if I'm working for Apple, Samsung, like these brands, they have offices almost in every country. And subnetting is not only in private, subnetting happens in public networks also. You get IP address from INA RIR, that is AppNic. I have a server where we have installed the labs like racks.nwkings.com, and you guys can access this website, right? So this is a URL, but on this URL has some IP like 203.181.25 like that. Okay, so this IP is my public IP, and this IP I got it from where? From my ISP. Okay, so I just bought one single IP or maybe two IPs, that is known as static IP. And static IP I have entered into my DNS so that if anybody goes to racks.com, so it will redirect to this. That is a DNS entry I need to create in my website. So static IP is to access anything from internet. So static IP is a public IP. If any big company is going to buy IP, suppose you work for Apple, okay, so they have a lot of servers like iTunes, from where you can stream the music, like Apple Cloud, where you can store your images and all, like Apple TV and all, so that the users can access this from internet. So Apple have public IPs, right? So they have a network, public pool, 17 network. So they are going to assign these IPs to the server, you can say that, so that these users can access, put, take their selfies and upload to the Apple Cloud or something. So just take an example, or maybe you can take an example of Facebook. So everyone needs public IP to access something. Even this appnik.net, this website is also having one public IP. We are going to connect two machines and we will see how they are going to share files with each other. Okay, we are going with the first practical. So like my two computers will be connecting with a cable and I'm going to assign IP address here. So I'm going to explain you one thing, that is IP address classes. We have three classes, class A, B, C. When any IP address start from 1 or between 1 to 126, you need to match the first part, that is first is network part. I'll explain. So if two computers are connected together, they have IP 1.1.1.1 and this computer is having 1.1.1.5. So in class A, any IP address start from between 1 to 126, we just need to check the first part. They are matching or not? Yes. So it means they will communicate with each other. What if I'm going to give 1.1.1.1 and here 2.1.1.1? First part is matching? No, right? So they will not communicate. So in B, when the IP address is between 128 to 191, we need to match two parts, guys, two parts only. It means when we have IP 150.1.1.1 and here we have 150.2.1.7, so just check first two parts are matching. No, my network bits are not matching. It means they are not in my network. This is the power of network bits. In class C, we have 192 to 223. So that is 3 network part. So suppose I got 192.168, 1.1, 192.168, 1.5. This is class C, where we are going to match 3 network bits. They are going to communicate. Yes. So this 127, that is for loopback testing. All your computers, when Windows starts, right, it appears a logo, all the services are in background, all icons of the files. So that is a self-hosted IP addresses. That means these are your internal IPs, which are not accessible or accessible from outside. We can't transfer. So what is IP address now? So IP address is a unique identifier. मतलब एक unique ID है हर एक device की. So it's like a unique identifier. Every device in this world needs IP address to talk with another device. Okay. So like if you call someone, suppose you are calling from India to Australia. Okay, you need a country code, then again a national code, then you type the number. So same like you dial someone and the another person get a dialed ring, right? So so that you guys can talk to each other. So same like IP address is a unique identifier like internet identifier, but full form is IP address. Okay, IP address. Okay, so all internet routing system, all internet devices works on IP address. So let's talk about in short. So what is IP address? It's a very big number. So it is available in two variants. So now you can see IP version 4 is 32-bit, which comes around 4 billion addresses. But this is almost exhausted. And now IPv6 have almost 340 billion IP address. You can't even count that. It's a very big number. Some people call this undecalion also. बहुत बड़ा number है, undecalion भी कह सकते हो. तो हमें IP address क्यों चाहिए? Why we need IP address? All internet has a table called global routing table. It is also known as BGP table. There is a protocol which is very famous, BGP, Border Gateway Protocol. So you can understand in a very simple language, internet has a table called global routing table. So you can see here, suppose this is your company and you have few servers, like you have you are a company like Facebook or any company, or maybe you are yatra.com or railway.com or any website, you name it. Suppose you have your servers, so you have to share your IP address. You get this IP address from where? Appnik. So from where you bought this? Appnik, and you are going to announce, you are going to share your IP addresses with global routing table. Why? When you announce this 202.1.2, so this is IP address. When you announce, then whole internet will come to know that you have some servers. Okay, you have some servers. तो जब आप अपने IP एड्रेसेस को ग्लोबल राउटिंग टेबल में डालते हो, तभी पूरी दुनिया आपको एक्सेस कर सकती है. This is called routing. When you announce, so how to share your routes to internet? You have to use a router. Okay, so in short, you are going to push your information to a router, then router is going to share your information to the global internet. So you can understand like this. So you push from one router and it will go, because internet is a network of network. So what is internet? Internet is network of networks which are managing global routing table. All big companies routers have global routing table. This is why if you take Airtel connection, if you take Geo connection, you can open google.com, facebook.com. So few sites are blocked because they have their own internal firewalls. So remember, IP addresses are not domain names. So domain name is your website name like google.com, facebook.com, that is domain name. And IP address is your like 202, any number is called IP addresses, right? 101 dot any 4 decimal number, if you have seen somewhere like 192, 168, तो वो एक IP address होता है. And when you see any open website like google.com, facebook.com, that is domain name. Okay, so that's all. So you can see, where do IP addresses come from? IETF, Internet Engineering Task Force.
So we are going to start today IPv6. It is of how many bits? Okay, so 128 bits. So it is almost like 4x, or it's even more bigger than IPv4. Okay, so IPv6 is so big, even you can give this IP to all the objects in the world. So still हमारे IP बच जाएंगे. Okay, IPv4 is just an address. Okay, so IPv4 is in binary. So you can see these are the fields in IPv4. So what is the limitation of IPv4? Why we are moving to IPv6? Because there is a address depletion. IPv4 is running out. Okay, so lack of end-to-end connectivity, because there are a lot of things we have to do, NAT and all. Okay, NAT will convert your private IP and public IP, and which will actually increasing the network complexity, that you have to convert the private IP into public, public into private. So IPv6 is a basic. In IPv6, you can see it is again developed by ITF, Internet Engineering Task Force. So ये देखो कितने IP होते हैं. So 1 billion has 9 zeros, and IPv6 is this much. So there are a lot of IPs, and the packet header is also improved. There is no need for NAT because itne zyada IP hain. We have a lot of IPs. So IPv6 header, if you check compare with IPv4, it is very simple: source IP, destination IP, and there is a version which is IPv6. This is a traffic class like quality of service. Suppose you want to send one packet on priority, so that is called quality of service. You need to improve the quality of service of the packets, which is this field traffic class. So flow label is an informed device to handle identical flow labels. Okay, like suppose you have a lot of traffic, okay, and how the device is going to handle that traffic. Okay, like kind of a cost, but it's little different. Payload is basically your data, next header, and hop limit is similar to your TTL value. Okay, so IPv6 is like it has a unicast, multicast. In IPv6 we do not have broadcast. Okay, so unicast, basically any IP start from 2000 to 3FFF is a global unicast. So most of the times you are going to see these IPs in IPv6. So link local is like your private IP address, or it's like a same IP. Like these are generated by computer itself. So here we have multicast address like 224 series hoti thi na, like class D series 224 to 239. So these are the similar multicast. The multicast of IPv6 send the traffic on FFA 05, FF06 for OSPF, FF09 for RIP, right? So 2 to 4 ki jagah FF something, it is going to append FF number, which is the IPv6 number reserved for multicast. Okay, you can create a loopback also. IPv6 has 8 groups. How many blocks? 8. So there is no like a specific class ABC in IPv6. ABC का कोई logic नहीं है यहाँ पे. So the simple logic is network and host. Suppose if you put a IPv6 IP and then you put a 64. Here also you give IPv6 and put 64. What is 64 network part? So it means the two computers should have the first 4 portion should be same. So ye bhi 64 means till here we are going to check if they are same, they will communicate with each other. So let me write in a IP. So first of all, how the IPv6 looks like, it's a hexadecimal number. So I will write like 2001 0001. Okay, then put a lot. You can put zeros. So how many groups? 1, 2, 3, 4, 5, 6, 7, and the last group is 1. So can you imagine, guys, this is one IP. ये एक IP है. So you can see 8 groups, 2001, 001, 0000000. In the last we have 1. Okay, so the similar way we are going to assign this IP on laptop 1. Like maybe I have given laptop here 0002. So if I'm going to give this IP with the /64, तो अगर मैं ये IP, okay, so remember we have how many groups? 1, 2, 3, 4, 5, 6, 7, 8. So ये एक group, in every group we have 16 bit, and it is going to write in the 4 digits. ठीक है? In IPv6 we can shorten the address. हम short में लिख सकते हैं. So how the computer is shortening it to very low number? कैसे इसने किया? So first of all, so whenever you see a consecutive zero, जैसे ही इकट्ठे zero आ रहे हैं, okay, so you can see just groups. So from where to where we have consecutive zero till here to here, right? So we can reduce them and we will put a double colon here where we have put here double colon. And this 0001 will be written as 1, and this 001 will be also written as 1.
Okay, so let's do subnetting. So we got a pool from where Appnik. Okay, so let's create a data center today. So data center is what? When we have a lot of servers and we want that people can access these servers from outside world. One single public IP is enough to access internet. Just imagine, like, if you are still a student in a university of almost 10,000 students, So tell me how many IPs they need to access the internet. They can still access the internet with one IP. How? Because these 10,000 computers will get private IPs, and all these private IPs are going to convert into one single IP, and with the help of a concept that is known as NAT, Network Address Translation. Okay, but when we are saying we have pool of 256 IPs from AppNic, what exactly it means? I am talking about a company where they have a lot of servers, and from internet people or anyone can access these servers, or maybe they are uploading the videos or maybe images. Because in one like, just take an example, when anybody uploads the images in Facebook, so tell me, all images are going in one server, or they have a data center with a lot of many servers? Lot of servers, right? So they will have a lot of servers. So they need a lot public IPs, or they can use one single IP. See, accessing internet, you can access the internet with one IP also. But if anybody wants to enter into your premises, or they want to access your servers, then you need public pools. Okay, got it? Let's take example 200.1.1.0, and this is a class C, so we always say /24. What is this 24? This is known as slash value, you can say that. In A class we have how many network part? 1. So this is known as /8 because it represents 8 network bits. In B we have 2n, so this is the reason we say this 16. And in C we have 3 network part, and this 888 is 24. So this is the reason I have written here 24. Now I want to divide this network into 4 parts for my Delhi, Mumbai, Chennai and Kolkata location. So how I'm going to divide this network? So it's very simple. So your IP address is of how many bits? 32 bits, right? So what I'm going to write here, I have network bits and I have host bits. So I have total 24 network bits and host bits 8. Right? So by default, how many IPs we are getting? 2 to the power of 8 is 256 IPs I am getting right now. Is how I have calculated my total IP address is of 32 bit. If class C is 24, the remaining 8, 24 plus 8 is 32, right? So the 2 to the power of 8 is 256. So it means I am getting 256 address from from this pool. But what exactly we want to divide this network into 4 locations? So tell me how we get 4 when we have 2 to the power of 2, right? So it means we will add 2 here. It means we will have 26 here. Okay, very simple. And from where we will get this 2 when we will reduce 2 here? It means 6 host bits. So when we want to divide this network into 4 parts, my network bits will be 26 now instead of 24, and I have reduced 2 here. Why I have reduced this? Because we need to balance it every time. I need total 32 here. 26 plus 6 also 32. I need to maintain this 32. So you can shuffle the numbers from here and there. So it means I am going to have /26, and 2 to the power of 6 is 64. So it means we will have around 64 IPs in every group, right? Let's take one another example. If I want to divide this network into 8 parts instead of 4 locations, I have 8 locations. So again, by default 24, we have 8 here. How we get 8? When we have 2 to the power of 3. So I'm going to add 3 here, 27, and I'm going to reduce 3 here. That comes 5. So 2 to the power of 5 is 32. So it means we will have 8 groups, and every group is of 32 IPs. Okay. So now the question is how I am going to write these IP addresses. Okay, so we were making 4 locations. So let's go back again with the 4 question. So again 24, I have 8 by default. So to get 4, my to the power of 2. So I am going to add 2 here, 26, and I need to reduce here, that is 6, right? We are going to assign the IP. So IP address would be 200.1.1.0. Okay, so how you calculate your 4 locations? There is a simple maths. So IP address always start with 0. Okay, and it always ends with 255. 26, so to the power of 6 is 64. So how I am going to write this 64? So just add zeros in the starting. 0 plus 64, 64. So again plus 64 plus 64, 128. 128 plus 64, 192. So before 192 we get 191. Before 128 we have 127, and before 64 we get 63. So this is how. So the IP address from 0 to 63 will be placed in Delhi. So here we are going to assign in Mumbai. Here this IP we are going to assign in Chennai, and here this network I am going to assign in Kolkata. Got it? Very simple. What is the sending process? So whenever any computer wants to go to another computer, so computer will actually calculate its binary value. So what would be the binary for whole IP? Might be 1100000, and then for 168.101.010 like that. Okay, so you need to calculate all 01s, and for 11 might be you have 0000. Yeah, so this is the binary for 1.11. So now computer, whenever you type any ping or any different IP, so computer is going to check its binary value also, and most of the values you can see up to this network the values are same. But you have given here /24, means /24 or subnet mask of 255. How many 255 by default? 3 times 255. So it means 3 networks should be matched, and whenever computer actually calculates the binary of both the machines, right? So for 2 the binary would be 00000010, right? You are getting a difference. So in 3 octets my values are not matching. It means this another device is not in my network. Can you see that? First portion is matched, second is matched, but third is not matched. So this is known as like ending process, where the system calculates the information. Also, how they calculate the network ID? Whenever this is source, this is destination, and there is a ending process. 1 is 1. Whenever we have 1 0, that is 0. 0 1 is considered as 0, and 0 0 also 0. So let's calculate 1 1 1 1 1 1 and rest all zeros. So this is I am doing ending. Okay. So 1 1 1 0 1 0 1 0. So 0 0 0 0 all zeros. Right. So here also you don't have to calculate. So this is the ending. So ending means you can see that both the information, means this ID and the third octet of these source and destination is different. So when we have this ending processes, the values are different in both the things, so it means they are not in my network. What is TTL and time and all, I'll explain. By default I'm sending 32 bytes of packet. So ping is a packet. Okay, so I'm sending 4 packets and I'm getting 4 packets reply. So my 2 PC are connected. I'm sending 4 ping request. This is known as echo request. Okay, and how computer understand this is the echo request? There is a code in it. and that code is basically 8. So this is a type code. So how my computer understand it's a request? Because when we send this echo request, echo is a type of message we are sending from PC A to PC B with a code that is echo request type code 8. That means it's a request, and B is going to reply with all 4 replies here. So that is echo reply. For every request, we are going to receive 1 reply. It means we are sending 4 packets. It means we are going to get back 4 replies. And the echo reply code is 0. So this is how your computer understand when they are getting, because computer is getting 0, 1, all the data in the form of 0, 1. So how it is getting its echo reply or echo request? Because when we are going to write this 8 into this binary form, like kind of this. So when these type of 0, 1s are coming from another device, it means we are getting a request and we need to send a reply back with all zeros. So if it's getting more complex, you can just simply understand it's a ping packet we are sending request and we are getting reply back. And this is a tool to check the connectivity between 2 devices. So by default, we are sending what type of size? 32 bytes of packet. Okay. And in how much time we are getting reply back? In 2 millisecond, 1 millisecond. This time represents how much time my computer is sending data to another device, and device is sending reply, and this reply is coming in 2 millisecond. Second reply I got in 1 millisecond. Okay. Third reply I'm getting in 2 milliseconds. So it varies, right? Sometimes it's 2 millisecond, 3 millisecond. It depends on the location also. If you are pinging google.com, obviously you are going to get more time because Google servers are at different location. We call this latency. We call this time also. You can say that delay. You can say that in network language. All these are common or same thing. So what is TTL over here? That is time to live. Suppose we are sending a ping to any device, but it's not actually present in my network. Suppose you are sending request from PC A to any device which is not in network. Okay, over the internet, it is very important. When you are pinging google.com, but mistakenly you are pinging some another IP, that IP is not available in the internet. So actually what happens, your routers, if you are sending ping request, your router is going to decrement this value with 1. Suppose you are sending request with 128, the first router will make it 127. The request is going with another router 126, 125. So if location is not identified, if location is not in my network or anywhere in the network, that packet will be discarded or dropped when the TTL value will be 0. So TTL is just like expiry date. Okay, I'm going to send a limit with 128. It means if we don't get this IP address within the 128 routers, I'm going to drop this packet. Got it? Why we have this TTL value? Because if we don't have TTL, the packet will keep revolving in our network and it will create internet loops. This is the power of TTL value. If we don't have anything in internet, it is going to discard it or drop after roaming to 128 routers. Okay, it means TTL value is like expiry date. If we don't get in 128 routers, I'm going to drop this packet. So that. What is TTL value? So TTL value is time to live. So why we have TTL value? TTL value is in IP packets. Okay, whatever technology works on IP, they have TTL values. Normally, you will not see in Ethernet frames, in layer 2 packets or layer 2 frames, you will not see TTL value. Why we use TTL value? To avoid the loop. So suppose this is your laptop, guys. Okay, whenever you send any packet to google.com, so whenever you send any traffic, also if it is a web traffic, if you do ping anything, so there is a router, and further in ISP networks you also have routers, and on the internet also there are many routers. So internet is nothing, network of networks, and you may have thousands of routers. So there are so many networks or routers in your network or in internet. Suppose you want to go google.com and by mistake you type some different IP. Try to go or try to ping 73.1.1.1. So if this server is not available on internet, what will happen? Router will keep searching where is the packet, right? So this TTL value actually gives some, it's like expiry date. Okay, so if I send ping 73.1 with a TTL value 64, so routers will forward the packet till 64 routers, because whenever you send packet, the router decrements value by 1. So the first 63, if you forward a further 62, 61, 60, and then reach. So now you can see we can reach to google.com. But if you try to ping any wrong IP which is not in our network, so we have expiry date of this packet. So once the routers keep searching for this information, if it is not available on internet, once the TTL value 0, the packet will be discarded. So TTL value is to avoid the loops. तो अगर ये TTL value नहीं होगी ना, तो पूरे इंटरनेट में loops हो जाएंगे. So in every packet, whenever you send outside from your network, any IP packet has a TTL value, so that you will not have loop in internet or in your IP networks. Okay, so this is why in Ethernet, let's talk about Ethernet, normal Ethernet. So when we connect a switches, so what happens whenever you send any L3 packet, this layer 2 device will only understand a layer 2 frame. So it will broadcast, okay, and whenever it sends information, frame does not have TTL value. So this is why the packet is keep rotating, and this is why spanning tree protocol developed, because we don't have TTL value in Ethernet frame. This is why spanning tree protocol discovered. Why we only have TTL in IP packet, not in Ethernet frame? What is solution for spanning tree protocol? Spanning tree is a by default protocol which is running in devices. It will block one port. If you have multiple links, it will block one port, because loop only happens when you have multiple links. What do you mean by link state protocol? So OSPF, when we are going to configure OSPF, so OSPF makes a database which is called link state database. OSPF makes 3 tables. That is, first is neighbor table, second is database table, and third is routing table. So this database table, so in OSPF, whenever you connect 2 routers, they become neighbor to each other. Okay, when you connect these OSPF, so they are going to send one packet which is called hello. We will discuss about that also. So, but OSPF makes one table which is called database, and it is also known as link state database. So if all 4 routers, they are going to make one table which is called LSDB, and in link state database, all the routers will have exact information. Okay, I'm considering all the 4 routers we are going to have in one area. Okay, so let me make it more simple. So this is called link state protocol. We are going to store all the links. Means if one router is having 2 links, we are going to store both links information in the database table. If this router is connected, this is also having 2 links. So this router is going to add these 2 links. So in total, how many links we got? This will be considered one link. This will be another. This will be another. So almost 3 links information will be stored into the link state database. We are going to connect 2 machines, and we will see how they are going to share files with each other. Okay. We are going with the first practical. So like my 2 computers will be connecting with a cable, and I'm going to assign IP address here. So I'm going to explain you one thing, that is IP address classes. We have 3 classes, class A, B, C. When any IP address start from 1 or between 1 to 126, you need to match the first part. That is, first is network part. I'll explain. So if 2 computers are connected together, they have IP 1.1.1.1, and this computer is having 1.1.1.5. So in class A, any IP address start from between 1 to 126, we just need to check the first part. They are matching or not? Yes. So it means they will communicate with each other. What if I'm going to give 1.1.1.1 and here 2.1.1.1? First part is matching? No, right? So they will not communicate. So in B, when the IP address is between 128 to 191, we need to match two parts, guys, two parts only. It means when we have IP 150.1.1.1 and here we have 150.2.1.7, so just check first two parts are matching. No, my network bits are not matching. It means they are not in my network. This is the power of network bits. In class C, we have 192 to 223. So that is 3 network part. So suppose I got 192 168 1.1, 192 168 1.5. This is class C, where we are going to match 3 network bits. They are going to communicate. Yes. So this 127, that is for loopback testing. All your computers, when Windows starts, right, it appears a logo, all the services are in background, all icons of the files. So that is a self-hosted IP addresses. That means these are your internal IPs which are not accessible or accessible from outside. We can't transfer. So now this is very important layer. So that is transport layer. When we discuss about 3 layers, so the data is in which format? Data. So now when the data comes to transport layer, it actually converts the data into segments. It means it will divide the data into multiple chunks or parts. Okay, means you are getting a data. So when the data is going to transport layer, it is actually segmenting the data into multiple parts. Again, hello is very small, so I'm just explaining you what is happening. So the data is actually converting, and so this is known as segmentation. Okay, and also this transport layer is responsible for sequencing. What is this sequencing? So it will actually add the number on the data. Why? Because when data is going from one PC over the internet to any another device or in your LAN network anywhere, so might be there is a chance the packet will be dropped. And when the data is going to B, so B will check, okay, I got 1, 3, 4, 5. I haven't received the second number sequence. Can you please retransmit? Can you send me again? So in this transport layer, we actually do retransmission also. But transport layer actually divided into 2 protocols. So all this retransmission, segmentation, sequencing all comes under TCP. Sequencing is used so that we can assemble or reassemble the data at the destination end. So now data is coming from above layer. Okay, so now you can just say that we have 2 trucks over here. So one truck is known as, you can say that it's a TCP and this is a UDP. So whenever we send any data with TCP, any packet is going from source to destination. So the destination is going to send us back a receipt that is known as acknowledgement. But when data is going with the UDP, we are just sending the data, but we are not going to get back the receipt of whatever we are sending. So TCP stands for Transmission Control Protocol and UDP stands for User Datagram Protocol. So whenever data is going with TCP, so it actually takes care of acknowledgements. So tell me, if anybody is coming with the receipt, who is more reliable, TCP or UDP? Because it is coming back with the receipt that I have delivered the data, so this is reliable. Where this person or this UDP truck is not reliable, right? And if data is lost, if suppose we are sending data, one box dropped in the road or somewhere, so it is going to retransmit the data. So we don't have any retransmission over here. No retransmission. It always believes in connection. So this is, in network language, it is known as connection oriented, because it always believes in making connection, but this is connectionless. So it has less overhead. Less overhead means whenever we sending data, we don't actually send a lot of many things. So it means there will be less size of the packet in comparison to TCP. So TCP takes 20 bytes and UDP takes how many bytes? 8 bytes. So what is that information? That is port numbers. We add port numbers here. So the bytes I'm talking here, 20 bytes, 8 bytes, it actually adds port numbers. There is a protocol number to it. TCP protocol number is 6, because these both protocols falls under IP. TCP works under IP and the protocol number is 6, and UDP works also under IP, that protocol number is 17.
Okay, so what we are going to do now, like we will see like how to configure a device. Like we will use a switch here. Okay, switch is a device to connect multiple computers. Okay, so we will connect computer 1, computer 2, computer 3, or maybe computer 4. So there will be another switch this side. This switch is also going to be 1, 2, 3, 4. Okay, we need to understand like there is a device called router. Okay, तो एक device होता है जिसे हम बोलते हैं router. So why we need this router? Because this is my LAN network. Okay, so this is my LAN network 1. Okay, so this is my LAN network 2. तो एक LAN network दूसरे LAN network से कैसे बात करेगा? How they will communicate with each other? They will communicate with the help of router. We can also connect with this switch, but what is the problem? We need to build this network as a one network. Okay, if you make this network as one network, अगर ये पूरे network में if you are using one IP address, then you can connect a cable from switch to switch also. Okay, suppose in this network you are taking, okay, like suppose all the IPs are like starting from 1. Okay, so this computer is 1.1.1.1. तो ये computer का IP है 1.1.2, 1.1.1.3, 1.1.1.4. Okay, so these are called IP addresses. These are unique IDs of computer. You can understand. Okay, any computer in a network need IP. So this side, this switch is on different network. Maybe this computer is 2.1.1.1. This is 2.1.1.2. This is 2.1.1.3. This is 2.1.1.4. So right now you can see this network is in a different network and this network is in a different network. So two different can talk to each other only with the help of router. Okay, so you can say that router is a network device which is used to connect different networks. So when you take internet connection at your home, you connect with the router. So home network always have a router. Why we have a router in home networks? Because router is connected with internet and internet is different network. Internet is a combination of different networks. So how your home network will connect to different network? You need a router, because a router is the device. Router is a network device which is used to connect different networks. Okay, second thing, router makes a table which is called routing table, which is very important, guys. So router makes a routing table for the decisions. Okay, what kind of decisions? Okay, suppose this is a router, this is a home network, but let's talk about company network. So suppose this is your company, okay, and this router is connected to multiple connections like Airtel ISP, and this router is also connected with the Reliance ISP. What is ISP? Internet Service Provider. So when you will, this is your company and this is your laptop. So when you access google.com, so maybe the router will forward traffic to Airtel. Okay, or you can configure this router so that you can forward your traffic to Reliance. तो हम router को configure कर सकते हैं कि हमारा जो LAN network है वो किस तरफ से जाए. You want to send traffic to Airtel or you want to send the traffic to Reliance. Okay, all this can be done with the routing table which defines or which understand the decision. So router is going to make the routing table automatically, but we have to configure it.
तो सबसे पहले आपको ये वाला मोड दिखेगा, इसे बोलते हैं यूजर मोड। तो यूजर मोड का मतलब ये है कि आप छोटी बेसिक ट्रबल शूटिंग कर सकते हैं। तो अगर आप प्रिविलेज मोड पे जाना चाहते हैं तो आपको इनेबल करना पड़ेगा। तो अब मैं कौन से मोड पे हूँ, प्रिविलेज मोड पे। अगर मैं इसे वापस जाना चाहता हूँ वापस यूजर मोड पे, तो आपको एग्जिट करना है सिर्फ। इनेबल आ गया, यहाँ इनेबल लिखते हैं, फिर से प्रिविलेज पे आ गया। या आप डिसेबल भी लिख सकते हैं, इससे भी वापस चला जाता है, बट एग्जिट ही करते हैं सारे मोस्टली। इसके बाद आपको देना है कॉन्फ़िगर टर्मिनल। ये किस मोड पे लाएगा आपको, ग्लोबल कॉन्फ़िगरेशन। मतलब राउटर का सबसे ज्यादा कॉन्फ़िगरेशन यहीं पे होती है, इसे क्या कहते हैं, ग्लोबल कॉन्फ़िगरेशन मोड। तो अगर आप यहां से पूरा काम कर चुके हैं तो यहाँ पे एग्जिट करेंगे। तो इसके बाद प्रिविलेज पे आ गया, दोबारा से एग्जिट। तो ये होता है आपका यूजर मोड, प्रिविलेज मोड और ग्लोबल मोड। ये प्रिविलेज मोड पे आज हम बेसिक कमांड्स देख रहे हैं कि कैसे कैसे क्या करते हैं। शो क्लॉक, सिंपल कमांड। इसके बाद शो रनिंग, प्रेजेंट कॉन्फ़िगरेशन, जो चेंजेस नहीं करता है। शो स्टार्टअप, अगर आपको खाली दिखाए तो कुछ नहीं करना, आगे चलो। शो स्टार्टअप। इसके बाद शो फ्लैश, ये फ्लैश मेमोरी जिसके अंदर आपका आईओएस होता है। शो फ्लैश में दिखा रहा है कि आपका आईओएस की फाइल का नेम क्या है, तो वो और भी डिटेल में देखना है राउटर कौन सी सीरीज का, शो वर्जन। तो राउटर के पोर्ट्स होते हैं ना, उनको आईपी एड्रेस देते हैं हम। शो आईपी इंटरफेस ब्रीफ, ये कमांड होती है शो आईपी इंटरफेस ब्रीफ। तो ये कमांड दिखाते हैं कि इंटरफेस पे क्या क्या आईपी एड्रेस दिया हुआ है। तो इसके बाद हम आईपी एड्रेस देना सीखेंगे। तो सबसे पहले मान लो हमने 2-3 कंप्यूटर लिए और उसको स्विच से जोड़ दिया, तो यहाँ से यहाँ आईपी दे दिया। बट अगर इनको इधर वाला कोई नेटवर्क, एक और नेटवर्क है, मान लो एक और लैन है, और ये राउटर क्या करता है, 2 डिफरेंट नेटवर्क्स को जोड़ता है, राइट। तो आप कैसे आईपी एड्रेस देते हो, कॉन्फ़िगर टर्मिनल। तो इंटरफेस फास्ट इथरनेट, कौन सा पोर्ट है इसके साथ कनेक्टेड है, देखो ये इंटरफेस FA00 में आ गए। तो ये कौन सा मोड हो गया, इंटरफेस मोड। एक मोड ये भी होता है, इसे इंटरफेस मोड बोलते हैं। तो यहाँ पे अगर आईपी एड्रेस देते हैं, आईपी एड्रेस 192.168.1.100, सबनेट मास्क आ जाएगा क्लास C का। और बाय डिफॉल्ट राउटर के पोर्ट क्या होता है, शटडाउन। तो आपको क्या देना पड़ेगा, नो शटडाउन। और अब इधर FA01 पे देता हूं मैं दोबारा से, कॉन्फ़िगर टर्मिनल इंटरफेस। अब FA भी लिख सकते हो आप, शॉर्ट फॉर्म। FA के बाद उसे पता है क्योंकि FA फास्ट इथरनेट ही है, तो 0/1। तो इधर मैं 2.100 दे रहा हूँ। आईपी एड्रेस 192.168.2.100। तो यहाँ सबनेट मास्क और नो शटडाउन। तो दोनों इंटरफेस कनेक्ट हो गए। थैंक यू।
What is DHCP? Okay, so DHCP stands for Dynamic Host Configuration Protocol. So when you want that your router should give IP address to your computers automatically. So in DHCP what happens, suppose this is my computer and this is a DHCP client. Okay, your Windows server, or maybe you can have a router as a your DHCP server. So it depends on company to company. Some configure on servers and some configure DHCP pool on router also. Okay, so if you have a very big company, you can configure DHCP pool in a server, and when you are a small medium scale enterprise, you can configure on a router also. And in our home connections, we use router as a DHCP server. So these are my servers. Okay, so they will work as a DHCP server, both the devices, and this will be my DHCP client. So there is a concept known as DORA. What is DORA? Client sends discover. So what does discover means? Discover means to find the DHCP server. Like maybe you have 100 computers in your networks, all are going to send a discover packet to find DHCP server. Okay, and now server will or router will check its DHCP pool table where all the IP address are written, and it will be like that all IPs are free or assigned. So whatever IPs are free means they are not used anywhere. It is going to send one free IP which is not allocated to client with the offer message. Offer message of any IP. Maybe this computer has 192.168.1.2. So server is going to offer IP address from the pool. What does pool means? Pool means like a group. Okay, maybe it has a pool of around 250 IPs. So one IP address is going to allocate to this client. So now then client is send a request packet. Okay, give me this IP. So request packet is to get the IP configuration. So in which packet we get all IP configuration? In the last packet acknowledgement. And in acknowledgement you get the here is the configuration. So in acknowledgement packet, the server will send the IP configuration details.
Let's talk about DHCP protocol. Okay, so this is a layer 7 protocol. So layer 7 protocol means that it will be either using the TCP at layer 4 or UDP at layer 4. Okay, so this is basically a service which is utilized at layer 7. Okay, so at layer 7 means that it should be having some sort of port numbers. Okay, so in layer 4 header, there will be a source port number and the destination port number, correct? So DHCP basically uses two port numbers, which is 67 and 68. One is for DHCP client and other is for DHCP server. So 67 is for server and 68 is for client. Now let's talk about what DHCP servers is used for. So let's say you are having a PC. So in your PC, there are two ways to define an IP address. The first way to define an IP address is you will go into your adapter. Okay, so adapter can be Ethernet adapter or the Wi-Fi adapter. Okay, and you can manually assign an IP address. You will manually give the IP. Let's say I give 192.168.1.1, and then you will give the subnet mask. Okay, and after that you will be giving the gateway. Okay, so all this information you are providing manually. Okay, and the second way to provide an IP address to a PC or any device is dynamically. So dynamically means that you are not using, you are not providing an IP address manually. You will be using some sort of protocol or service. Okay, so the service which is used to provide an IP address dynamically to any device, that service is known as DHCP. So the full form of the DHCP is Dynamic Host Configuration Protocol. So let's see how the DHCP works. Now, as I told you, there will be a DHCP server and there will be a DHCP client. So client is the one who is requesting for the IP address, means who requires an IP address. So in this case, my laptop is a client. Okay, and DHCP server will be the device who is providing the IP address. Okay, so let's look into the packets. So let's say this is your PC and this PC is connected to a switch, and then the switch is connected to a DHCP server. Now PC doesn't know that what is the IP address of the DHCP server. Okay, because PC wants to send the packets on the interface. I told you that if you are having an protocol, if you are using a protocol which is layer 7, which is greater than layer 2. Okay, so it will be having the layer 2 header, it will be having a layer 3 header, and below that it will be having a layer 4 as well, because this is a layer 7 protocol, and under that it will be having a layer 7 header. So all the headers will be there because this protocol is a layer 7 protocol. Okay, now PC at layer 2, what information it will add? Okay, it will add its own MAC address as a source MAC. So let's say this PC MAC address is A. Now, as this PC doesn't know about the DHCP server, it doesn't know about what is the DHCP server, what is the IP address of DHCP server, what is the MAC address of DHCP server. So for destination MAC address, it will put the broadcast MAC address. So broadcast MAC address, for now I'll tell you, it will be all Fs. Now at layer 3, it is not having an IP address. So at the source IP, it will put all zeros. Because this device is not having any IP address yet, it has to request for the IP address. Okay, so at layer 3, it will be putting the source IP as all zeros. So what will be the destination IP? Now broadcast IP address will be 255.255.255. Okay, so this is the broadcast address at layer 2, and this is the broadcast address at layer 3. So at layer 4, the source port will be, what will be the source port? So source port number will be 68 and destination port number will be 67, because this is the server port number. Okay, And at layer 7, there will be a DHCP header. So let's look into the flow, how the flow looks like. So there will be a DORA process. So the first packet which the PC will send will be a discover packet. Now the server will reply back with the offer. Offer will contain the IP address. Okay, so this server, DHCP server, will contain a database from which it will provide an IP address to the PC. Okay, so it will contain a database and it will provide an IP address from that database to this PC, and that we will be doing the configuration on the DHCP server. Okay, so in the offer, the DHCP server will reply back with the IP address. Now, if this PC will accept that IP address, it will send a request message. Now, the third message which will be sent by the PC will be request. Okay, so the request message will contain that, yes, I want this IP address that you offered me.
Hi, you are watching the recording from one of our live session. Hit like, share, and subscribe for more future updates.
Okay, so once the DHCP server will receive the request message, it will send the acknowledgement.
Okay, so EIGRP. So what is the full form of EIGRP? That stands for Enhanced, okay, Interior Gateway Routing Protocol. So EIGRP से पहले एक protocol था IGRP, but this IGRP is no longer used because this is obsolete. Okay, so Cisco made first IGRP, which is Interior Gateway Routing Protocol, and after some time they released the Enhanced Interior Gateway Routing Protocol. This is a derivative of Interior Gateway Protocol. So this is the new version, and it supports VLSM, it supports subnetting. And this EIGRP also support high speed interfaces, like high speed interface metrics, because every protocol calculate the metrics, right? So remember, like if you studied about RIP, so what is the metric of RIP? Metric is hop count. Like RIP always check the hop count, that how many routers are coming in my way. Okay, so tell me, like if you have studied RIP, suppose this is one router. Okay, so this is my destination network, like 10.x.x.x suppose, and there is one another path. Okay, so this is 1 GB path. I'm talking about RIP right now. The below links are 10 GB. So tell me, if you are using RIP, which path this router will follow if you are using RIP? The first path A or path B? In the case of RIP protocol, so RIP only checks the hop count. So you can see, if we go from path A, the first and 2, the hop count is 2. The path A has a hop count of 2. तो दो router बीच में आ रहे हैं अगर A path से जाएंगे. Okay, but if we go from the B path, the hop count is like 1, 2, 3, okay, 4. So the hop count is 4. So the RIP routing protocol is going to use this as the best path. So this is why we do not use RIP in industries, because RIP is not an intelligent protocol. RIP do not check bandwidth. Okay, maybe someone will ask you, maybe in interviews, that why we do not use RIP. Obviously, we can only use maximum up to 16 routers in RIP protocol, but another disadvantage is that we can't check the bandwidth. RIP do not check bandwidth, it checks the hop count only. But when we talk about EIGRP or OSPF, though both protocols check the bandwidth. Okay, so if you use EIGRP, tell me which path we will follow. अगर हम यहाँ पे EIGRP configure कर दें, instead of RIP, if we will use EIGRP, which path will be used? Then B path will be used. B path will be used because B path has 10 GB links and the A path has only 1 GB links. And if you use OSPF also, which path will be considered? OSPF use करेंगे तो भी कौन सा path use होगा? So when you will use EIGRP OSPF, the path B will be the best path, A is not the best path. So when we talk about EIGRP metric, okay, so EIGRP, like in EIGRP, we can support up to 255 routers. Okay, so we can use up to 255 hops, but in hops means devices, right? So we can go up to 255. So the default value is 100. By increasing that number, you can go up to 255. Autonomous system. Okay, many students have confusion about autonomous system in EIGRP and BGP. So first of all, AS number in BGP and this EIGRP is completely different. Why we need AS number? To run the BGP protocol. Okay, so there is no significance in AS number or in EIGRP. So why we need AS number? Because every company, we will learn this in BGP, but you can understand every company who runs BGP, they need this number called AS number. It is like 1265535. Okay, the companies who runs BGP, suppose this is one company. Okay, so maybe this is another company. Okay, this is another company. Maybe they are service provider or something. So when they are connected with each other, they communicate with the protocol which is called BGP. Okay, BGP is the only protocol in the world which is managing the internet. Okay, we can use any AS number in EIGRP because that is local to the router. Suppose this is one company, this is one company. Okay, so when we connect multiple routers in the company, these routers are going to run protocols which are IGP, Interior Gateway Protocols. IGP stand for Interior Gateway Protocols. Okay, so this is another company. This company will also run IGP protocol, okay, inside the company. So what are IGP protocols? Like RIP, EIGRP, OSPF, there is one ISIS. So these all are interior gateway protocols. But whenever we connect from one company to another company, that is called EGP. That stands for Exterior Gateway Protocol. Okay, and there is only one protocol under this category, that is called BGP. So it means whenever we want to connect with the different companies or maybe different ISPs, then we use BGP, and then you use this number called AS number. Okay, so when we talk about the actual AS number, we use in BGP. So remember this. So when you will configure EIGRP, the command is like router EIGRP and the number. Okay, so you can number like a 70 or 80, router EIGRP 1, router EIGRP. So this number is also known as AS number. Okay, so why we have AS number in EIGRP? So we can run multiple EIGRP process. So suppose we have a router here. Between these two router, you can run EIGRP 1. Okay, maybe EIGRP 1. So between these two routers, you can run EIGRP 2. So you can see this router is running EIGRP 2 on the left side and EIGRP 1 on the right side. Okay, so this is one important aspect why we have AS number in EIGRP, so that we can run multiple EIGRP process. OSPF areas. Okay, so the first question everyone knows, okay, there is a OSPF area and then we need to connect all the OSPF areas with this area 0. These routers are in my OSPF area 0 and these router may be in area 5, area 6, area 7. Okay, so if you want to connect area 5 to area 6, then it is mandatory to have area 0. And another term you may have heard is that all areas should connect to 0. One interface can belong to only one area. Suppose this router has one interface, one cable or interface port, whatever you want to say. So this interface is going towards this router. So I can add this interface in only one area. I can't add one interface in different areas. So as you all know, OSPF is a very big protocol, like you can have unlimited hops, means you can add as many routers you want. तो आप unlimited router भी लगा सकते हो इसमें. So to understand why we have areas, let's consider all the routers are in one area. Okay, so why we have areas? So consider all these routers are in one area. When the OSPF network increases or area grows in size, when area grows, what will happen? The network links will grow, right? You will have lot of network links. Your number of routers will increase, obviously. अगर आपका नेटवर्क बड़ा हो रहा है तो उसमें राउटर और उसके लिंक भी बढ़ रहे हैं. So if you increase the area, obviously the routers, the links are increasing, correct? There are n number of reasons why link flaps. Maybe Ethernet cable is not correct, or maybe fiber cable have problem. Flap has many reasons. Okay, so if link flaps, do you know what will happen? So in short, the first thing will happen is whenever anything change, we are going to do the again SPT, what we discussed, spanning tree calculation again. And due to this, what will happen? The link state database will increase. Obviously, let me write here. The link state database size will increase. Link state database, LSDB, means if you have many number of routers, many number of links, then LSDB table will also increase and becomes unmanageable, correct? Because it will be too big to manage. And when the link state database increases, there is another problem that consumes more memory. And if it is consuming more memory, what will happen? There is a delay in SPF computation, and then it is going to be what we call LSA flooding. Consider this. If you do not understand what LSA is, consider whenever anything happens wrong, routers are going to send update to all the neighbors. And what will happen? All their respective neighbors, they are going to send update to all their neighbors. Their neighbors will send update to all their neighbors. And what will happen? In short while, like you will have a big LSA flooding in your network. So this will cause more CPU resources, SPF will have issues, the tree will take time, and then your network becomes unmanageable. So there could be n number of problems you will have. Okay, so if we have areas, like few routers are in this area. Okay, so when we have areas, what will happen? If there is a flap or anything happens in one area, it will only be in your area. We will not send LSA flooding, or there will be no LSA flooding whenever it happens. Okay, we can have area 0 in between also. Area 0 is also known as what? It is called backbone. Okay, and let's talk about the network. So this is area 0 and you have many routers. Let's consider 4 routers. I'll put these routers on the border. Okay, and you have few routers here, and this is connected to this router, and this is called like area 5, and you may have a few routers here. This is another area, and let's connect this also. This is area 7. So obviously this network will work from area 5 to 7 because between this area 0 is coming. But these routers are called internal routers. So internal routers is member of one area. And these routers, which are, you can see this link and this link, both links are in area 0. So this is called backbone router. But these links, you can see this is 0, this is 5. So this is called ABR, area border router, which is member of multiple areas. And this router is also in 0 and 7. So this is also ABR. And all these routers are internal routers. Okay. So there is a special router in OSPF. Like if you try to connect, suppose in both the routers I am running EIGRP. Okay, so now you can see this router is having EIGRP on this interface, and on these interface you have OSPF. Here OSPF, here also OSPF. So even if it is a single interface in different routing protocol, this is what we call ASBR. So any router which is member of multiple routing protocols, So that is called ASBR, Autonomous System Boundary Router. So if you are new to this concept about ASBR, it's very simple. If you run any protocol, like if you run RIP here, so which router will be ASBR? This router, because it is also having OSPF in this direction. So this router will not become ASBR because it is only running RIP. It's not mandatory that you should have ASBR in area 0. Any router in OSPF can become ASBR except a stub. Okay, so this is area 0. So Cisco recommends we can have around 40 to 50 routers in one area. Okay, but usually we have seen there are 100 plus routers in one area. It totally depends on your design. Okay, but normally we can have a limit, and you can connect one link or either two links area to another, because if one link goes down, your area will not be separated. If both the links will be down, so this is what we call in OSPF partitioned area. So in short, so it will reduce LSA flooding. Means if you have any problem, you will only update to your neighbors, okay, OSPF neighbor. We will not flood to different area. And due to this, we are going to manage the OSPF properly. Yeah, so yes, reduce LSA flooding. Another is like a reduce resource utilization. Yes. So why we need area 0? If this router, when we add this interface in area 1, okay, suppose this is going inside area 1 routers. Okay, let's consider there are many routers. This interface going in area 1 and this interface may be going in area 0. Whenever you have any router with multi areas, what we call this router? Area border router. In OSPF, we will call this area border router. ABR stands for area border router. So this ABR, whenever we have any interface in area 0, then only we will have ABR. If you do not have area 1, or suppose you have area 2 here, so in OSPF, according to OSPF design, this is not ABR. Okay, if you have area 1, area 2 this side, so this router will not be ABR anymore. So according to OSPF design, when we have any single area, whenever we have any interface in area 0, so our router becomes ABR. When we have ABR, then only we can share routes from one router to another area. Okay, if you do not have ABR, you can't send area 1 routes to different area routers. Got it? So if you want to send routes from area 1 to area 0 or maybe any different area, so you can only send routes from area 1 to different area or area 0 if you have ABR. If you do not have ABR, the router is not going to forward the information, because only the ABR router send one special type of message which is called LSA3. Okay, this is a special type of message or update that one area routes will go to another area routes with the help of LSA3. ABR is responsible for LSA3.
So the topic is OSPF LSA. LSA stand for link state advertisement. So there are different LSAs. The first LSA is called router LSA. When you connect like 4 routers within one area, so suppose all these 4 routers are in area 1. These all routers will create a table which is called OSPF database table. And inside table, suppose this router ID is 1.1.1 router ID. This is maybe 2.2.2.2. This is 3.3.3.3. And this is like 4.4.4.4. So what will happen? All routers will send their router ID, their basic information with each other by using router LSA. Okay, means they will update the information. Suppose we have LAN network here. So whatever LAN networks you have, whatever networks router have, so they are going to share link state update packet, and inside LSU you have a lot of information. So that is like which LSA you are sending right now, router LSA. So inside router LSA you are sharing your networks. Okay, that my ID is 1.1.1, my LAN network is maybe 192.168.1.0. So you are sharing your information with your area router. So okay, so sharing updates within the area. All routers will send router LSA. Okay, So means we will not send this LSA outside the area. They are going to maintain their router IDs inside this. Okay, so inside the router LSA, we will add 1.1.1 IP. Okay, so 2.2.2.2, 3333, 4444. Okay, means all the router IPs, all the information inside the database table. Because if you have 4 routers, then 4 entries will be there, 4 router LSA will be there. Okay, so the one router is connected with 4 routers. In this router database table, how many router LSA we will have? 1, 2, 3, 4 and 5 him itself, means all 5 routers. So this is called router LSA. So all routers will send router LSA, and inside router LSA you have the router ID or the internal router information. There are 4 subnets, okay, like 4 different networks. So all these routers are going to maintain a table called network LSA. So the second LSA is called network LSA. So the network LSA is generated by DR router. So that contains the router ID of DR. Okay, suppose in this case, maybe this is DR, this is DR. DR share information with other routers. So you update to DR and then DR update to other routers. So the network LSA is generated by DR, and like in this 4 router, maybe we have around 2 DR. Suppose this is DR and this is DR. So it will contain the router ID of the DR router. So whatever is DR, so this is called router LSA and this is called network LSA, and network LSA is called LSA2 and this router LSA is called LSA1.
Okay, so first of all, BGP, we call this BGP protocol version 4, and it's an inter-domain routing. So we need to understand why we use BGP. Okay, so you can see this is one company, understand its networkings. Okay, so this is Airtel. This is a service provider. You can take any AT&T, Sprint, whatever you want. So if networkings has multiple branches, like this branch is Delhi, Mumbai, Chennai, Bangalore. So this is our India office. Okay, so this is Delhi, Mumbai, Chennai and Bangalore. So 4 locations. So which protocol you will use inside the company? So you run interior gateway protocols, like they have the category RIP, EIGRP, OSPF, BGP. So now Airtel. Okay, so Airtel has many routers, right? Maybe thousands or maybe more than that. So maybe they have 10,000 plus also. I'm just giving you one idea. Okay, so now you can see. So tell me, like if I am running interior gateway protocol in networkings, so what we are going to run inside the Airtel? This is a service provider network, right? They have many routers. Okay, so what protocol I'm going to use inside Airtel? So is this IGP or it's EGP? So IGP stand for interior gateway protocol. Okay, and there is another category which we call EGP. EGP stand for exterior gateway protocol. Okay, and there is only one protocol which is under EGP, that is BGP. Okay, so tell me, Airtel is going to run BGP on all the routers, or like we will have some OSPF or some other. So I'm just giving you an idea, like in ISP network, these are called PE routers. Okay, these routers are called provider edge routers, because PE routers are the routers which will connect it to the customers. Okay, like this. Like if you have multiple customers, so these routers will be going to connect with the customers. You have many customers, like Airtel has many customers. So Airtel is going to have connectivity with all the customers with these router, which is known as provider edge routers. In terms of MPLS, we call this router because this is my customer router, which is getting connection. So this is what we call CE router, customer edge router. These routers which are not connected to any customer, these are called provider routers. Which routers? P routers. So I'm going to run for all the connectivity between all the routers. I'm going to have interior gateway protocol. So yes, guys, we will run OSPF or ISIS between this. So people use OSPF, IS both. Okay, many service provider uses OSPF, some uses ISIS. Okay, काफी लोगों को ये प्रोटोकॉल के बारे में नहीं पता. This is intermediate system to intermediate system. So router का पहले नाम क्या होता था? ISIS.
So as I told you, you have two gateways. Maybe you have multi-layer switches. All these multi-layer are connected like this. You can bundle these links also with EtherChannel. And below this, you have all your LAN switches. And these switches also have connectivity with another multi-layer also for better failover if one side link goes down. So this is the connectivity, and multiple systems are connected. So all these are in different VLANs also. Suppose you have created VLANs, VLAN 10, VLAN 30, 40, 50, whatever. So this is a multi-layer switch where you are going to connect your VLANs with the help of switch virtual interfaces, which is SVI. Okay, so between all four devices, you can run any protocol like EIGRP, or you can run OSPF. Okay, so these VLAN routes, suppose VLAN 10, VLAN 20, VLAN 30, all these routes will be on this device, which is L3 switch. So this L3 switch will share these routes with gateway 1 with the help of EIGRP OSPF. So now gateway 1 and gateway 2 is connected with ISPs. So you have taken an internet connection from AT&T, and you have taken a connection on gateway 2 with another ISP, maybe Tata. Okay, so these both locations are connected with internet. And on internet, you have different servers like Google, Facebook. So this is the scenario, guys. This is how you access internet. But when we run BGP, so we are going to run BGP here between gateway 1 and AT&T. And on gateway 2 and Tata, here we are also going to run BGP. Okay, to run BGP in this company, we need one number which is called AS number. So we do not need two AS number. On both the gateway 1 and gateway 2, we are going to use one single number.
BGP is the only protocol which can influence incoming and outgoing traffic in the world. BGP is the only protocol which can manipulate incoming traffic. But all other protocols can only be used for outgoing traffic. Like if you run OSPF, okay, so you can give the cost 10 here and 20 here. So which path OSPF will take? 10 cost path, right? So you can only influence the outgoing traffic. If you want that all your incoming traffic will come from this side, but you do not have to touch this router. Without touching this complete internet connectivity, we will put BGP configuration here, and automatically all your internet like Google, Facebook, whatever you want, they will understand and they will follow this path. This is only achievable in BGP. So the attributes for incoming was MED and one was AS path prepend. And for outgoing traffic, there are multiple ways like wait, you can use local preference. So what are these? Like these are the attributes which you use so that you can change your incoming and outgoing traffic behavior. Another thing, why we use BGP? We use BGP so that we can advertise public IPs. Okay, what is public IP now? So public IP doesn't mean only one single IP. So this is the internet and this is your company. Okay, and this is ISP, which is connecting you with the internet. Okay, ISP is already connected with internet, and there are many ISPs which are connected to internet, collaborating with each other. This is why the whole network of a network is internet. Means internet is nothing, network of networks is called internet. So now this is your company. Suppose you work for HCL, or you can take one more example of Apple. Okay, Apple has many public websites like iTunes, like you can play music, you can watch TV. So even you can take example of Amazon. Okay, so these all are big customer, right? So they have their own public IPs. They all, like you are sitting here, this is Airtel and you guys are sitting here. So this is home users, because home users are also getting internet. Okay, you can access Amazon.com, you can access HCL websites, Apple.com. So how you access? Because we have on internet, we have big routers, big devices. All ISP have big tables, which is called BGP tables. This is called internet table. And what is internet table? Internet table is BGP table. BGP ही internet table बना रहा है. BGP is the protocol which is making the internet table. Amazon is running BGP so that you will get a connection and you will forward your route to the internet. And when this route is all over the internet, so anyone can access Amazon.com. So the same way HCL has a public IP, so they are going to put BGP. Okay, you will configure BGP, and we are going to advertise this public IP. You will give the network command. All the company networks will be going to shared with internet, because all they go into the BGP table, which is called internet table. If everyone knows where is Amazon, where is HCL, where is Apple, obviously they are connected. So all we are connected with each other because of this BGP. Why you are using BGP? You can also take a default route, right? आप normal एक router लेके default route से internet ले लो. Why you are running BGP? Because of these two reasons, we can change incoming and outgoing traffic, and we can use for advertise public IP. Okay, so these are three companies. So you can say all will have a different number. This is called AS number, like AS 100, 200, 300. Okay, BGP is also known as AS by AS protocol, means they connect with each other with the AS connectivity. Like all devices, they can connect with each other. You can have multiple devices also. So I'm just showing you that. So when we connect between different AS, so this is called eBGP, external border gateway protocol. And when you are running BGP between all your locations, this is what we call IBGP. IBGP means internal BGP. When two routers have same AS number, like 100, then only you can run IBGP. It means if all companies have their own unique AS number. What is this AS number? This is called autonomous system. So first of all, you need to understand what is INA. Okay, so INA is Internet Assigned Number Authority. Okay, and under this INA, like they have RIR. INA is a big organization. RIR means this is known as Regional Internet Registries. APNIC, Asia Pacific Network Information Center. Then we have LATNIC. This is for Latin America Network Information Center. Russia, okay, RIPE, RESUX Internet Protocol Exchange. Then we have AFRNIC, Africa Network Information Center, and in America Regional Internet Number something. Okay, like if you want to get the AS number or any public IP, you will contact directly APNIC, right? Because ISP give you 5 IPs, 10 IP, 20 IPs. Okay, but if you need a block, if you need 24, if you need /16, if you need /8, or maybe a big IPv6 range, you will contact the RIR. If we can go to any APNIC website and we will type RIR. Okay, so so you can see Internet Assigned Number Authority, and you can see this image also for your better understanding. Regional Internet Registry. Okay, so this is the image. Okay, just to check, you belong to which RIR? APNIC. They have office in Australia, because Australia is part of APNIC also. So you can see like what exactly you need. You need IPs, you need AS number. So what exactly you need? So you will say I need IPs. Okay, so you can see become a member and what are the cost. So you can see the fees and all. Start your application now. So you have to log in obviously, and then you can go for the further process. But if you check the fee, so like if you want /24, it is going to cost annual membership of Australian $1180, around 60 to 70,000 for yearly for 256 IPs. Just an average. You can just convert this into INR and you will get the details. Okay, and this is another sign up fee also. This is one time registration fee. So this is the minimum we need to buy. We can't buy /25. The minimum number you have to buy is 256. So this is the cost of IPv4. In the same price, you will be getting IPv6/48. ASN means autonomous system number. All the BGP devices, like if you have any, you are on internet, you need to buy a AS number. So you can see this is reserved. So 1 to 23,455. This is called public AS number. like anyone can use, but you need to pay. Like if you get the /24 from Appnik, तो आप Appnik से जब IP लोगे तो आपको एक AS number भी मिल जाएगा. Okay, so you can see help guide for ASN request. So click on ASN request and you see that you need to put your name, email ID, account number, and then you can request for the AS number. If you want to run BGP, like many companies are not ISP. Many companies like Apple, Wipro, okay, HCL, Samsung. So all these companies are not ISP. They are product-based companies and service-based companies, right? They have their own network and they need AS number. They have their own public IP. Like I have shared, like Apple has 17 network. Apple wants to send this to internet table. What they will do? They will take the BGP connectivity in link, because when you take internet, you get two options. You can take a default route, and the second option you have BGP. But what is the use of BGP? You can share this route with the complete internet. So you are using this 17, you are using BGP so that you can forward this to all internet routers. Okay, and to run BGP in your office, in your company, what you need, because when you will be going to configure BGP, the BGP command was like a router BGP and the AS number. And the AS number you have to give whatever you will get from Appnik, from RIR.
Why we need BGP? So first of all, like you are a company, you have only one router and you just need internet connectivity, and this is ISP. An ISP provide connectivity so that you can connect to internet. So this is your LAN network. You have a lot of computers, servers, right? So that's your internal network. So in this case, you need normal routing because you have only one connection, that is ISP. So you just need normal routing that you can use. Which routing? Default routing. If you need normal internet connection, you put a default route and forward all your traffic to ISP. And you know this thing, what in CCNA we learned default routing, like IP route 000, then again 000. It means any network, any subnet mask, I will forward all my traffic to ISP. Suppose ISP IP is 1.1.2, so you will put all your traffic to 1.1.2. So in this case, you do not need BGP because that's not required for your network. So then we have another connectivity where your router gateway 1 has two connections with same ISP, okay, both. So you have same network, like some computers, servers, but this time you have two links. This is primary link A, this is primary link B. Okay, you can say this is your 100 Mbps, this is your 50 Mbps, right? Okay, so just you are getting both the connections from one ISP. Okay, so in this case also you can use default routing and you can create the same static default route, which is IP route. Okay, so suppose we have two IP addresses now, 1.1.2, 2.1.1.2. So you can say IP route 0000, 0000, and then you can say 1.1.1.2. Then you can also create another default route, which is IP route, because you have two links, na? So that's why you will put two default routes. Okay, and but in the second default route, if you want to use this as a backup connection, then you can put it by default. What is the AD value of default route? 1, because default routing or static routing both are considered in Cisco. They have AD value 1. So by default they have AD value 1, and in the second default route you can put type 2, and you can type 1 and 2 also, like this also. So what will happen? Your all traffic will go from A path, but in case if A path go down, automatically the router is going to install this routing table and it will forward all your traffic to 2.1.1.2. So that's called floating default route or floating static routes also. Okay, whenever you change the AD value in the static routes or default value, they are called floating static routes. Okay, but this is the scenario. So in this case also BGP is not required. Then why we need BGP? Right, I'm showing you these two states. Okay, so this connection is called single home. So this type of network, when you have single ISP, single connection, that's called single home. In single home, BGP is required? No. Okay, so where in this case we have one ISP but two connection, that's called dual home. dual home. So do you think in dual home we require BGP? No. In these two designs, we do not need BGP. So in another case, the similar design, you have gateway, the same type of network. Okay, so this is like server, but this time you have ISP1 and this is ISP2, okay, which is further connected to internet, right? Obviously, so now in this case, when your company gateway has two internet connections and you just put a default route, right? Okay. But now the question is, do you want to manipulate the traffic? Does your company want you to send outgoing traffic from this side and you want all your internet traffic will come from this side? Do you have that kind of requirement? Okay. So do you have route manipulation requirement? Do you want to really manipulate the path? You really want that Google traffic will go from this side, Facebook traffic will go from this side. Do you want to play with the traffic? If yes, if it is yes, then we have to use BGP. If it is no, then it is no BGP required. So if you want to play with the traffic, okay, I want to send traffic for Google from ISP1, I want to send a traffic to Facebook from ISP2, then it is called route manipulation. If you want to change the traffic according to the company requirement, okay, then BGP is required here. In this case, this is called multi-home because you have two home. Home means ISP, okay, multi-home, and in multi-home we can run BGP, okay, but depend according to your company requirement, because I have seen a lot of real industry networks where they have multi-home but they are not running BGP. BGP is the only protocol which can manipulate incoming traffic, okay. There are a lot of other protocols like OSPF and all, they can only change outgoing traffic behavior, but BGP can change incoming traffic behavior also. So that's the reason BGP is used, because we can change the incoming traffic, that which link you want to use for your incoming traffic. You want all your traffic to come from ISP2, not from ISP1. So we are going to start EtherChannel. Okay, so what is this EtherChannel? So basically bundling the links. Okay, so whenever you connect a switch with another switch, okay, so whenever you connect one port, there is no problem, but whenever you connect two port, one port will be blocked. Whenever you connect three port, that is also blocked. When you connect the fourth port, that is also blocked. Means one port will be operational at one time and rest all the ports will be in block state. Okay, so why it is blocked? Because the switches is running one protocol which is called STP, okay, spanning tree protocol, which is blocking this port. Why? Let's take example. Computer A, this is computer B. So whenever we send any traffic from one port, there is no issue. Okay, but when we have two port, so when we sending broadcast or any packet, the packet may come back from this link. Okay, so this is why one port gets blocked. If you have three links, the packet will come from this way. This is also why blocked. So it means one port will be operational so that you will not have loops. Okay, so to avoid loops, the ports are getting blocked. And who is blocking these ports? This is a protocol called STP. We are learning EtherChannel, which will bundle these links and we will not waste these links. So if we bundle these links, they will be considered as one port, not four ports or three ports. So अगर हम इनको bundle कर देंगे तो क्या होगा? It will be better, right? So EtherChannel, first of all, why EtherChannel is used? So that we can bundle the ports, okay? So this is also known as link aggregation. Like bundling of links is also called link aggregation. But Cisco call this EtherChannel. And you can see here we have two links between all three switches. So you can see the ports are blocked there, because whenever the device sees a loop, तो जहां भी switch को loop दिखता है वो port block हो जाते हैं. And why we need two links? That is the most important question, because industry works on redundancy. What is redundancy? Multiple links is called redundancy, because if one port goes down, the traffic will go from another link, right? So like for primary and secondary, multiple links like for primary and secondary or backup. this is why we have redundancy. So when we have multiple links, STP, okay, which is called a spanning tree protocol, will block the ports so that we will not have layer 2 loop. So what is EtherChannel? Like we are going to bundle these links. So if one switch is connected with one port, the port will be blocked. If two switches are connected with one link, the port will be blocked. No, right? So if we have multiple links, so you can see we have two links, and if we bundle them together and we can show this switch, this is not two port, this is one port, so they will not be blocked, right? So agar main in sare ports ko, if I'm going to bundle them, the switch is going to understand this is a one port, not two port. And when we bundle them, so they will be considered as one virtual link, logical link. So they are known as physical links. So when we bundle them, that port will become one port and that will be logical. So we are going to learn network automation. Right now, why we need network automation? First, we need to understand the problems in the current network right now. Okay, suppose when there are many routers connected with each other. Okay, suppose these are your different cities like Delhi, Mumbai, Chennai, Kolkata, all are connected. So when you have very big network, you need more staff. So right now, another problem, if any engineer you are hiring, many engineers, like you need expertise on one vendor. Suppose you have Cisco devices, like these devices are Cisco, you need Cisco engineers. If you have Juniper devices, you need Juniper engineers. Okay, so if you have Arista company devices, you need Arista engineers. So this is why companies are looking for multi-technology or multi-skill engineers also. But this is very rare that one people know all the things. Okay, all what they are doing, like they are working on these devices and daily either they are checking the logs, either they are doing some configuration, but most of the things what a network engineer is doing right now, it's not productive. So right now, whatever the work they are doing, they are all repetitive tasks. So we need to eliminate these repetitive tasks. So this is the problem. तो जब network automation की बात आती है, what is the advantage of going to the network automation? When we are going to configure the network automation, it is we are going to automate means automatically things will happen, like which things, like configuration. Okay, we will also test the configuration. Okay, we will also deploy the things, like all the configuration, test, everything will be done automatically. Everyday task like backup, okay, like checking the health of device, okay, basic functions, all will be done automatically. Repetitive task will be eliminated. Or will be controlled, and also it will also improve my network service. So most of the network issues comes with the human errors also. When you are actually doing automation, it is rare that humans will do mistakes. So there are multiple like automation, like right now the network automation going well in the data center networks. So in data center, there are many advanced devices, okay, very big devices or the high-end devices called Nexus. And these all devices are controlled by one controller, which is called Epic. Or this is also known as ACI also, Application Centric Infrastructure. So all these devices, if you have many devices, so they all can be controlled in the data center with this technology called Epic. So automation is doing good in the data center and network. So the same way, cloud is going well in the market right now, cloud networks. Right now, if you talk about AWS, Azure, or Google Cloud Platform, even there also, there are some scripts, there are some concepts which is like Docker, Kubernetes, there are many things in cloud network also, the things are getting automated. Like suppose you want to run 100 Linux servers and you need to install maybe some application on 100 Linux server. So this type of automation you will see in the cloud network automations or cloud automations. तो डेटा सेंटर और क्लाउड में तो हो ही रहा था अभी तक, बट राइट नाउ even the wireless networks are getting automated. So wireless network, the best example of wireless network is Cisco Meraki. There is a solution from Cisco which is called Cisco Meraki. This is a wireless SDN solution, or what we call automation solution, where you will control the Wi-Fi of all the locations from one place. Like all your Delhi, Mumbai, Chennai, Kolkata, New York, Dubai, all things can be all Wi-Fi controlled from one place, which technology is known as Cisco Meraki. Okay, so now we have new technologies in the market from past few years. So in the local area network, this technology is known as SD. Cisco call this is SD access. तो ये एक टेक्नोलॉजी जिसे बोलते हैं SD access. And in the WAN, there is a technology which is called SD-WAN. So, but yes, these are the network automation things. Both technologies are doing good in the market. SD-WAN is more popular, but SD access is also doing good in the market. So, कोई भी network device होता है, whenever we talk about these network devices, like either it's a router or a switch or either a wireless device, so they can be configured with two methods, but you know only one method, which is CLI. But there is some another method, which is called API. Like CLI stand for command line interface, API stand for application programming interface. So we can access the devices from application programming interface, but many devices do not support APIs. Suppose a router, guys, which is connected to another router with a fast Ethernet interface. The similar way, like when we talk about the software, because they are virtual, तो जो software होते हैं, softwares do not have the physical connectivity, they have virtual connectivity, which is called API. So API is used among all software to make compatible this software with this software. Okay, so what is SDN? So we can actually control all our network from controllers. So SDN is not a actually technology, it's just a general word. Okay, this is just a general word. The technologies are SD-WAN, SD-Access, okay, Cisco Meraki, wireless solution, Cisco ACI or APIC. So there are many softwares, many companies like Velo Cloud, which is from VMware. Like automation is not about future, automation is already going on. मैं आपको एक चीज और बताता हूँ. So right now, like if we talk about Delhi, Mumbai, Chennai, Kolkata, right now we have all connectivity like this. Maybe we are connected with the internet and all. But tell me, if you want to configure Delhi, Mumbai, Chennai, Kolkata devices, so do you have to go to all the routers or you can control from one location? Obviously, you can do telnet, SSH, but still you have to log in with their IP addresses manually, differently. So inside these devices, you have two planes. One is called control plane. All your routing protocols, all your routing entries, everything, it's related to your control plane. This is done by data plane. When you send a traffic from computer A to computer B, okay, so when that router is forwarding this traffic, and that is data plane. And there is one third plane in the device, which is called management plane. Like accessing the device is called management plane. Okay, so this is all our current traditional network. What if I tell you that we will put devices with the latest methods? Okay, nowadays like V-Edge or kind of these devices. So they are programmable devices. All these are programmable devices. So there is a main controller. This is called controller. And we are going to manage all these devices from this controller. Okay, so it means we need a software. We need a software to control the hardware. It is called software defined networking. Okay, this term is called SDN controller. We manage kind of a device is a controller. It's like a software, okay, which is installed in servers. Okay, all these locations which are like Delhi, Mumbai branches, ये जितनी भी locations थी हमारी. Okay, all these locations are connected with this controller. Like these are like maybe our routers, maybe our switches, maybe some firewalls, because most of the advanced network devices, they support controller nowadays. Okay, so these kind of connections between controller and network devices are called southbound API. The above device is a controller which is a software, and these devices have software installed in their devices also. So tell me how two softwares interact with each other with the help of API. Understand now API? There is a top layer also where we are going to manage the software with some kind of Python. We are going to manage the software maybe with some language called Java. Okay, but still Java is not that popular. Python, Ansible. Okay, so these are some network automation languages. Okay. So this link between the controller and this applications which are like Python, Ansible and all tools, this is called northbound API. What is the difference between MPLS and internet? So in MPLS, like you connect your head office and branch office with a private connection, not over internet. Okay. And what is this internet connection? Obviously that you are connecting your head office and branch office with the internet. But in that connection, you need a firewall because you want to secure your network, because you are connecting your branch office over the internet and your public IPs are open. Anybody can attack you, right? So if you are making connection with the head office, branch office and all, whenever you have internet connection in your corporate connection, you should have a firewall so that it will protect you from the attackers, and people can save their data and their important documentation, websites, servers from attackers. Right. So MPLS is a dedicated connection. Nobody can attack, nobody can hack, because that's a private connection between head office and branch office. Like obviously it is physically secure. Internet is not secure. You can make secure with some protocols like IPsec, VPNs and all. But MPLS, they have their own private connection. Like a lot of companies are using MPLS so that they can connect their head office with branch office. You need to understand the terminology of MPLS. So this is like example, this is my ISP network. It is like a fast way to, or a technology which will work on labels, not on IP address. Okay, so consider this is ISP. So this is customer. So all the customer routers are called customer edge. So you can see in customer A, we have office in Delhi, and customer A office we have in Mumbai. So ISP help Delhi office clients to connect with Mumbai office, because already they have cables between Delhi and Mumbai. Their cables to forward your data from one branch office to head office. Okay, it is like a road on rent. Okay, that you are paying for that MPLS connection so that you can use their hardware and connectivity, because you cannot put your Delhi to Mumbai your own cable. Delhi to Mumbai is almost like 3,000, 4,000 kilometers approx. So consider ISP is third party for you, and this third party will connect your Delhi and Mumbai office with the technology called MPLS. And customer routers are called customer edge. And the customer routers, when they connect with ISP routers, ISP means internet service provider. So that's why these routers are called provider edge. And then they connect with some core network. The core network of ISP is called provider router. Okay. So provider routers connect with provider edges, and provider edge routers connect with the customer edge. Provider edge are also called LSR. That's a other name, label edge routers. So MPLS is a technology which uses labels. Whenever you forward any route, suppose you forward 10.1.1.0, So this router will add a label 10.1.1.0 is maybe having a label of like 50. The provider edge routers which are connected with customers and provider routers which only connect with ISP. If you talk about normal VPNs, so VPNs stand for virtual private network. So there are two type of VPNs in the market. One is called like ISP VPNs or customer premises equipment based VPN, or you can simply say ISP VPN. And one is called customer VPNs or network based VPNs. Both are ISP VPNs only. These are L2 VPNs, L3 VPNs, and these are MPLS VPNs. So that is totally for ISP and that is all totally from customers. Okay. So means there is a topic called IPsec. So customers can connect their head office with branch office with IPsec, with the GRE, but GRE is not secure. And these are some L2 VPN. Okay, layer 2 tunneling protocol, point-to-point tunneling protocol. Okay, so these are few other protocols which are used by customers to connect their offices. Okay, and customer L3 VPN like IPsec and GRE also widely used. So yes, lot of big companies are using MPLS, but a lot of startups, they are connecting their head office, branch offices with the normal internet connection with these protocols like IPsec and all. Okay, in L2 VPN we have another like VPLS, virtual private LAN service. Okay, pseudo wire and VLL, I think virtual lease line something. Okay, and L3 VPN, normally we use this, that's called L3 VPN with the BGP and MPLS. Okay, so now it is company choice and ISP choice that what they want to use. Maybe between their two locations they are using L2 VPN and maybe further their location they are using L3 VPN. So it totally depends on the network. So basically then what to choose, whether we should go for MPLS or whether we should go for internet path. So the answer is, if your company is running very critical applications like audio, video or remote desktop, MPLS is a perfect solution, because MPLS is like a physical link and that link is not shared. MPLS is a dedicated link between Delhi to Mumbai, right? Nobody is coming between us. That's why it is far costly. Internet is like normal internet connection. Router to router, like you can use internet, but if you want to use MPLS, then you have to connect with ISP. You cannot run MPLS because MPLS is a technology from ISP. So we are going to learn wireless today. Okay, so what is wireless LAN? Wireless LAN means we are going to connect the network into our home offices or in the campus environments. Okay, so WLANs gives you portability so that you can sit anywhere. You do not have to sit at one particular position. You can just take your laptop and go in cafeteria, have a coffee, come back to your seat, chat with your friends, work with your clients, and go again back to the cafeteria. So this gives you more portability. Okay, so these are some type of wireless networks. Wireless personal area network. Like in networking also we have LAN, MAN, WAN. The same way wireless LAN, wireless MAN, wireless WAN. Okay. So when we talk about wireless technologies, Bluetooth is also one of the wireless technology, but it is on the distance of up to 100 meters, where this is a technology WiMAX, which can go up to 50 kilometer of the wireless range also. Okay. Worldwide interoperability for microwave access. So additional wireless technologies in the market is like cellular broadband. Okay, like mobile, 3G, 4G, 5G, these are called cellular broadband. Okay, so we are using GSM, SIMs and CDMA and all these technologies for in cellular broadband. But nowadays 4G, 5G is more popular. But nowadays we have also satellite broadband also in the market. But it is not for the urban location. Mostly it is for rural locations because the speed and all things are not that great. Okay, so whenever we talk about wireless, the standard comes 802.11. It means it is a wireless standard. Standard means the radio frequency, all the signals of Wi-Fi, radio. Okay, your all these frequencies are called radio frequencies. Okay, and they have standard in Wi-Fi. The wireless standard is 802.11. Till here they are very old. Nowadays we are using 802.11n. 11AC, 11AX. This is the latest, which is called Wi-Fi 6 also. Okay, so by the way, if you do not know what is hertz, so the number of cycles per second is called waves. Okay, so one wave is called 1 hertz. This is one wave. Okay, this is called 1 hertz. Okay, this is a frequency. But if the frequency is like this, so now you can see per second you have now more waves. Okay, so if we type and we have like this, so now you have more waves. Okay, so here you have less waves, average, now you have higher waves. This is called the hertz. Okay, so when you have too much frequency in per second, those are called like megahertz, gigahertz, terahertz. So if we have 1000 in 1 second, they are called 1 kilohertz. So when you have too much in 1 second, there are a lot of waves. Okay, too much Wi-Fi signals, they are called megahertz. Okay, when you have millions or like billions of waves in 1 second is called gigahertz. So your Wi-Fi is working on 2.4 gigahertz. And there is another frequency which is like 5 gigahertz. It means in 2.4 you get this much waves per second. इतने ज़्यादा waves होते हैं 1 second में. And this, if you multiply by 5, it is called 5 gigahertz. So in the latest ranges, they have now MIMO technology. So this is 802.11 AC, which is 5 gigahertz. And this is 802.11x, which can go 2.4 and 5 gigahertz both. And it can go, the speed is going up to in Gbps also. In 802.11 AC, the speed is vary between 450 to 1.3 range. If you have taken an internet connection from whatever ISP, so you got a 1 GB link, okay, and they have a wired router, they have not given the wireless to you, okay. So, but if you want a wireless device at your home, so if you buy the normal device, it will give you around 300 to 500 Mbps speed. But if you want more speed, then you have to buy 802.1 AX. आपको ये लगाना पड़ेगा अगर आपको Wi-Fi पे 1 GB speed चाहिए, more than 1 GB also. So the devices are called 802.11 AX. Okay, so if you see the frequency, number of waves per second is very lengthy, very big. But when we go for X-rays, gamma rays, okay, so the waves per second is increasing a lot. So wireless ranges, they work here, okay, and X-ray, gamma rays are very, very, very impactful, right? Even for our health is not good. So these are the 3 regulatory bodies where everyone needs, like any device or companies, they need permission or they need regulation licenses from these organizations. Okay, like International Telecommunication Union, Institute of Electrical and Electronics Engineers, Wi-Fi Alliance. So they promote the Wi-Fi devices, they promote the things, okay, but they also give you the license. Okay, so let me tell you. So VPN is basically virtual private networks. Okay, what is VPN? VPN is a virtual private network to create end-to-end private network connection. Okay, so let me give you one example. Suppose you have an office in Delhi and you have office in Mumbai and you have office in Chennai. Okay, and maybe some of your users are working from home. Okay, so they are using VPN for connecting with their office. So over the internet, so when you want to connect to your Delhi branch, your Mumbai branch, or maybe your Kolkata branch, okay, so when you connect over the internet, Delhi and Mumbai, okay, Delhi and Kolkata, Mumbai and Kolkata, like this, so this is called VPN. Okay, so VPN is a virtual circuit. Okay, VPN is a virtual circuit which will help us to make our private WAN. Okay, so because private WAN is secure, private WAN is very important. So you have 2 types of WAN. One is private WAN and one is public WAN. So public WAN we all are using right now, which is called internet. And private WAN, we use multiple concept. In private, for private WAN, we need VPN. So you can see this is a business partner. Okay, so over the internet, this is the main site. Maybe this is a head office, and all these branch offices are connected with this head office. And there is a mobile worker like who is doing work from home, so he can also connect to this office. Okay, so these type of WAN, guys, this type of connection is called site-to-site VPN. And when my employees or maybe the mobile workers, they are using their laptops and connecting the VPN from any software which is connecting to the head office, so that VPN is called remote site VPN. Okay, so usually when we talk about VPN, so VPN is also encrypt the data so that nobody can access the data publicly. So if we are sharing data over the internet, the data is not secure. So we will use secure VPN tunnel so that my data will be confidential. Okay, so when we talk about VPN benefits, so what is the benefit? So first of all, the cost benefit. So we do not have to buy private connections. Suppose if you want to connect a Delhi to Mumbai or maybe Kolkata, if you ask internet service provider to connect my Delhi office, Mumbai office, Kolkata office, so this solution is very costly. Okay, so this solution is very costly. Okay, but when we use a VPN, because VPN can be used over the internet, okay, we will use one protocol which is called IPsec. And third is scalability. Scalability means suppose you have 3 branch offices, maybe in future you have 5 more branches. Okay, so over the internet, just you have to connect your offices with the VPN. And VPN can be like implemented across wide variety of WAN links. Okay, you can have a VPN on the 4G links, you can have VPN on the internet links, broadband links. So you can use any type of connections to use the VPN. But when we talk about the service provider VPNs, so these are different ones. So these are not actually VPN, these are called VPN services. Okay, so this is called MPLS technology. So we have layer 2 MPLS, layer 3 MPLS. So as a customer, you will not run MPLS. So when you become a service provider, so if you are Airtel, if you are Reliance, so these companies uses MPLS. Okay, so if you learn MPLS, you will be able to apply to the service provider companies. But if you want to stay with the enterprise companies, like product-based companies, then you might do not require the MPLS knowledge also. Okay, so yes, various companies are looking for both mixture. Okay, that's the different case.
Before moving further, we have something special for you. If you want to learn hacking and other major tactics related to cybersecurity, you should definitely enroll in our Cybersecurity Masters program, where you will get more than 150 hours of live training directly from industry experts, with 24/7 access to world's biggest virtual labs. Apart from this, even if you want to make career in in-demand IT field and want to land a good package, we have master's programs for them too. Enroll now, link is in the description. Now let's continue.
Why we want to connect with VPN? I have 3 branches. So maybe this is my Delhi office, this is Mumbai, this is Chennai. Okay, so over the internet, I will buy the normal routers, the router which support VPN. Over the internet, I'm going to connect all my offices with internet, and over the internet, we are going to connect all the offices with VPN. So maybe in Mumbai we have server. So maybe in Chennai we have some another server, and maybe in Delhi we have a tele server. So we have different servers at different location. We have a LAN network here, we have hundreds of users available in Delhi. So now all these users, they want to access these at tele server. Okay, suppose these are accountants. So tele is basically a software for accountants. Suppose these all 4 accountants wants to access the tele server which is in Mumbai. So we are going to connect my office with Mumbai office with the help of VPN. And with the help of VPN, what will happen? My private network, suppose this private is 192.168.1.0 and this is 192.168.2.0. So these are 2 private network. Can I ping your private IP? Because the routers which are used by ISP, So ISP routers block private IP. So then how this VPN technology is able to connect? What is happening? So we are actually building a tunnel and we are sending our private information inside the tunnel. That is basically called VPN. So we are hiding the information from public, that we are not actually dealing with the private to private IP. We are dealing from this router to this router. ISP will come to know, okay, the traffic is going from the Delhi router to the Mumbai router. But in actual, we are sending my internal traffic inside the tunnel, where a tunnel is built between R1 and R2, right? Between Delhi and Mumbai.